initiative named Digital Egypt Builder Initiative. Digital Egypt Builder Initiative is a unique initiative that was launched by the Ministry of Communication and Information Technology and announced at the opening of number of educational establishments by the President of Egypt in September 2020. The initiative falls under the pillar Egyptian Human Development, one of the key pillars of MCIT strategy for building digital Egypt. Professor Goto, would you like to add something before Dr. Hoda proceed with her presentation?
Oh yeah, this is Goto from Tokyo, Japan. I'm very interested in the digital transformation in Egypt. Okay, so I'm really interested to hear from the Hoda Baraka, Ms. Hoda Baraka. Yes.
Thank you very much. Dr. Samir Saghir, would you like to add something to the introduction to Dr. Hoda Baraka before she proceeds? Dr. Samir, I think you are muted.
Samir?
Okay.
No, he's not in the table.
Okay, so Dr. Hoda, without any further delay, please proceed. We are all ears to listen to your valuable presentation.
Thank you very much, Professor Hassan, and thank you very much, Professor Goto. I will actually share my screen now. And can you see the presentation?
Yes.
All right, so let's start. Okay, so my presentation today is actually about one of the most important initiatives for the Ministry of Communication and Information Technology. It is about Digital Egypt Builders Initiative, or we just call it DEBI. Okay, so DEBI now is becoming one of the flagships in the Ministry of Communication, and actually is very much presented to the higher education institutions. I would like first to thank, of course, EJUST for actually providing us this opportunity to talk about the initiative. I would like also to thank Dr. Ahmed Hassan as Egypt IEEE chapter to give us also this opportunity to present this initiative in this conference. The initiative actually has been launched also in the inauguration of the Egyptian Japanese University. So this was in September 2020 at Burj Al Arab. It was launched by the Minister Dr. Amr Talat in the presence of the President El-Sisi. And it was highlighted that this initiative, of course, is important both for the Ministry of Higher Education and also for the Ministry of Information and Communication Technology. Actually, my presentation will be around three folds. The first one is about what is the vision for DEBI and what are the goals and objectives that we think we should achieve by this initiative. Then what is the program, how it is structured, and finally, what are the partnerships that we are looking at for a quality implementation for this initiative. So we'll start first with the vision. And as Dr. Hassan mentioned, this unique initiative was launched by the ministry in the presence of Egypt President in September 2020. DEBI falls under the pillar of Egyptian human development. And this is one of the key pillars for MCIT strategy for building digital Egypt. As you just mentioned, Professor Goto, it's very important for Egypt in this era to strengthen all the components and all the pillars related to building Digital Egypt. And definitely human resources is one of the main priorities to make sure and to strengthen what the building Digital Egypt can be, and what this initiative can provide for Digital Egypt. When we look at the human development pillar at the Ministry of Communication, it is not one time fits all. No, actually we have several initiatives at the ministry, and these initiatives are provided by directly by MCIT or by MCCIT affiliates, for example, the Information Technology Institute, the National Telecom Institute, by ETIDA, by the Technology Innovation Center, TIC, and each of the initiative that is implemented is actually targeting a specific target group, okay? And it's like a pyramid. So these initiatives build on each other. Each of segment of the pyramid actually target very specific group, starting with the awareness all over Egypt. And this is definitely, it's one of the very important things that we are doing, and that the ministry have started long time ago since its establishment, to ensure that when we talk about information and communication technology, this is a knowledge that is transferred to all Egyptian citizens in all governorates. So it's basically the foundation of the pyramid. It's about awareness, it's about the preliminary education on very simple tools associated with ICT. Then when we go upside in the pyramid, why it is a pyramid? It is a pyramid because from one segment to another, the number of trainees actually is reduced based on the type of the training that is provided. So from medium quality training, so high quality technology, to emerging technology specialized training. And then at the top of this pyramid, we can see DEBI in the top. Why DEBI is in the top? Because DEBI actually targets a niche group. Okay, so we're not talking about masses. We're not talking about students in all faculties. No, we are actually selecting very specific niche of students and trainees that DEBI is here for helping and supporting these students. We will actually define what is the target group, who are the students, and all of that in the next few slides. So this is basically about providing a professional master degree for the trainees in DEBI. So what is DEBI Vision? DEBI Vision is focusing very much on two types of graduates: the graduates coming from faculties of engineering and graduates from faculties of computer science. Actually, we are also looking for faculties of science in the Department of Mathematics branch, computer science, because also they can fall under one of the tracks of DEBI. So what we are looking for these students, actually, we would like to empower these fresh graduates to become the world-class experts and leaders capable of the implementation of Egypt Digital Vision. Whether we're calling them, that's why we are calling them Digital Egypt builders. Okay, so they are here to help and support and to contribute to our beloved country, Egypt, in its digital vision. Strategic goals, we have different strategic goals. One of them is targeting actually the graduates, the trainees, and it's about preparation of the new transformational workforce. So everything now is transforming, it's digital transformation, and this actually initiative is also preparing this transformational human workforce. The second objective is about developing new state-of-the-art technology programs. And this is also quite important, and it is very much aligned with what the Ministry of Higher Education is currently doing with new universities established, with new programs that is also currently progressing in all the universities, even the already established universities. So it's basically we need to have all the emerging technologies with new programs built in this initiative and in the higher education institutes. The third strategic objective that we think is also very crucial is how to align that education part with the industry. So this collaboration between the industry and the academia is important in this initiative, and it is one of the main contribution that the Ministry of Communication have done in the last maybe 10 years, is that always in all our initiatives, we would like to have one objective is to reduce the skills gap between what is required in the market and actually the graduates from the academia. And a lot of support has been always done from the industry in this direction with the institutions of the Ministry of Higher Education or through the initiatives that was implemented by MCIT. And that's why we think that this also objective is extremely important. So when we talk about human workforce, it's important not only to provide these students with the technology part, the state-of-art technology, but also to build them as future leaders. And we will see in the program of Debbie how we are combining the academia part with the training part, with the leadership part. Okay, it's very important to ensure that we would have an output that will combine future technology skills, but also it will also have the leadership, the language, and all the information and knowledge required. For the programs, which is a second strategic objectives, it's very important that we understand that DEBI is not only working with international institutions, but actually DEBI will be implemented in cooperation with our Egyptian faculty members. And this is one of the things that is very important in the framework that has been put for DEBI. We all know that we are currently in COVID, and that most of the teaching process and the learning process is done online. Even our conference is done online today. And that we will not be able to get professors coming from abroad and to help us in the implementation in Egypt. So the model will be a hybrid model. This hybrid model is a bit different than physical and online. It is physical and online, but the physical part will be the responsibility of the Egyptian staff, and the online part will be the responsibility of the international partners, which means that this will also achieve our second goal, which is how to build the capacity, the education capacity for our Egyptian faculty members, starting from the teaching assistants all over to our professors. Again, the third objective is about the partnerships, and I think it's extremely important to see this partnership for the international universities with the industrial bodies, the local universities also with the industrial bodies, and all of that is extremely important for achieving the strategic objectives of DEPI. So this actually our vision for this program. So let's now move to the second part of the presentation, which is more about what is the program, how it looks like, how we actually try to put this framework all together, and why. When we started thinking about DEPI, we actually have looked about what are the top jobs for 2020 around the world, what is the salary range for these jobs, and what is the growth for each of these jobs. And according to this, if we can look at this table, for example, we can see that the top job growth is for the artificial intelligence and machine learning engineer, and then the data science, and then the security, and then comes what we all know about software engineering, data analyst, IT manager, database administrator, all of the other, I will not say classical or traditional, but the jobs that existed even for a long time, but from a salary point of view, still they are alive. But the growth here is not as much as we see in the top three jobs, which are the AI, the data science, and the security. Based on this analysis, we actually chose 4 tracks, and we proposed these 4 tracks for DEPI to start with. The first track is about the data science and artificial intelligence, and we actually mixed both tracks together. So it's not artificial intelligence separately and data science, but actually it's one combined track for AI and data science. Second track is about cybersecurity. The third one is about IoT and robotics and automation. And finally, a 4th track about digital arts. Each of these tracks, of course, has a number of educational objectives. When we look at the cybersecurity, for example, it's about developing skilled workforce. We all know that the dependency of the cyber now, or about the ICT, is crucial in all our day-to-day operations. And cybersecurity is becoming one of the very challenging risks in all nations. And definitely, we need to prepare our workforce to protect Egypt from potential cyber threats, and at the same time, making sure that everyone can do his work. This is something that I always ask, this compromise between, okay, we can be very secure, but at the end of the day, we cannot do anything of our day-to-day operation. So we need to be smart in our cybersecurity policies, and to ensure the business is up and running, and at the same time, we can protect all our operations and our businesses. So from basic knowledge to protect and defend computer system and networks, to identify and to analyze computer security breaches, and also to prepare these graduates to implement, to monitor all the cybersecurity mechanisms that will help to ensure any information technology assets. Moving to data science and artificial intelligence, we see currently that artificial intelligence is in all applications around us. And I think it's extremely important to prepare our workforce for artificial intelligence. From the practical point of view, to solve problems that before it was very hard to find solutions for such problems, to manage complex artificial intelligence projects. It's becoming now more and more important for engineers to find intelligent solutions that are definitely based on AI. At the same time, when we combine this artificial intelligence knowledge with the data science, both tracks actually help each other and definitely provide our students with a very strong tool to help them to design, to create, to be innovative in defining and designing new solutions for challenging problems that exist around them in their country or actually in other countries too. The part of IoT, robotics and automation, we all know that this is also becoming emerging. I wouldn't say emerging because now we have IoT, Internet of Things applications around us. We see advancement in robotics, and we see the integration between the IoT, the sensors, and the robotics in several automation processes in industrial application. I mean, of course, the vehicles is one of the applications, but we can also see much more application in the industry side for mixing robotics with the IoT and automation. So we believe that also this is one of the tracks that we would like to focus on in our first year to make sure that also here we are combining the artificial intelligence with the sensors, with the IoT and the robotics. So students will be enabled to acquire expertise in gesture recognition, machine learning and movement capture and analysis. Last but not least, this track, digital arts, it's more about, okay, so we would like to see engineers that are creative, innovative, that are producing videos, movie makers, even simple website development. So it's more about the digital arts, the virtual reality, how to integrate all these technologies together to actually to digital marketing. So this is somehow a track that is not very much classical traditional track, but it is a more innovative and creative track. Still, this track will start in September 2021. And currently we are investigating and exploring different universities that will support the launching of this track. So how is the program structured? One important thing is that this program is 1 full year. Okay, at the end of this 1 full year, students will acquire a degree of a professional master. Of course, when we say 1 full year, it's 3 semesters, 12 months. It's not scholar year. It's a one full calendar year. And one of our challenges actually with the universities is that some universities actually provide the master's degree in 2 years. And this request for the one full year, 3 semesters consecutive, was definitely one of our main discussions with the universities. So it is 3 semesters. It starts with a core module for whatever track, and then we will have 8 months to complete the number of credit hours required. In parallel to the specialized discipline, we will have a graduation project in the last semesters that may start, of course. Students can think about what are the ideas they want for the graduation project even before the last semester, but they will work on their project in the last semester. So this is actually what we have here. So 4 months of core module, 8 months specialized discipline with the graduation project, and to get at the end the master's degree. So what we have at the bottom of this structure, we have all other requirements for the program. So what are the other requirements for the program? We have 2 main programs related to the professional master degree. One is English language, which is definitely is very important for the students to enhance and empower them for the English language. And the second part is about building future leaders. So we have complete program for leadership, for project management, for communication skills, for research skills, that is also given during the one full year. So the one full year actually will not be only the professional master degree, but in addition to this, we will have the English, and we have also the leadership program. It's a 30 credit hours on 10 courses. So this is the maximum. Some of the universities would say, okay, our professional master is 27 credit, which is fine. So it's between actually 9 and 10 courses. One of them is the graduation project. For the project itself, we have 3 different choices. Actually, students can actually be enrolled in one of our Digital Egypt project. So this will be one of the government projects that is implemented with any organization, with any entity in the government. The second one is, or the second choice is a project in cooperation with any international or local company in Egypt. And the third choice is, okay, I have an innovative idea. I would like to explore this idea, and I would like to start this whole idea as an entrepreneurial project in this program. So these are the 3 choices for the graduation projects that the students can choose of and actually agree with the supervisors on different the track he wants to continue. For the leadership and management program, actually it's all about communication skills, negotiation skills, presentation skills, leadership and management. And you can see that we have a very strong leadership and management program that is put in place that will be provided through the full year, so that we can actually prepare these students to be a future leader. So what are the certificates that the students will acquire from this initiative? First of all, you will have a professional master degree in one of the tracks that is proposed by Debbie. The second one is the industry certificates. So currently we are working with a number of multinationals, and we all know that these multinationals have their own certificates, like for example, Microsoft, VMware, Oracle, IBM, and all of them. And it's also one of the prerequisites to be graduated from this program is to acquire at least 2 certificates from the industry with a maximum of 4. So from 2 to 4, also the initiative will support the certification process, the vouchers for these certifications, and the training itself from the multinational companies. He will get also an international certificate in leadership and management skill, and also an international certificate for the English language. What are the criteria for admission? First of all, it's a BSc in engineering, computer or communication or electronics or biomedical departments, computer science faculty, or a graduate from Faculty of Science, Mathematics Department, branch computer science. The most important thing is that all international universities wouldn't accept a GPA, a cumulative GPA of less than 3.0. This initiative is targeting fresh graduates. We can actually extend it to 5 years. It requires 1 complete full year dedication, of course, with a clear status for military, because students will be hosted actually in the venue of the initiative. Last but not least, to be admitted in any of the international universities, you need actually to pass and to fulfill the English proficiency test, whether it's TOEFL, whether it's IELTS. Some universities now are talking about Duolingo. I mean, whatever the requirements of the international universities, students should pass this requirement before to be admitted and accepted. Okay, of course, we accept students from all governorates, and our target is to reach 1,000 students for the initiative. How the initiative is implemented? It is implemented with 4 main partners, with the top international universities, with the ICT multinational and local companies, with 2 partners, one for the leadership, Dale Carnegie, and it's very well-known multinational company for leadership skills. And also for the English proficiency, we are partnering with Berlitz. So students will actually acquire like 4 levels in English proficiency, independent completely from the English proficiency test that they will get before getting into the initiative. We currently are talking and discussion, and we are in discussion with several universities around the world, of Canada, USA, Sweden, EU area, and also in the Far East. Even we have discussions with Korea. We tried actually with Singapore. We had also a preliminary meeting with Japan. And discussions are continuing to get the best international universities for this program. What would be the role of the international university? Of course, the overall supervision for the academic part first, the professional master degree. University will issue the professional master degree and whatever certificates coming from this university. It's a co-design for the program between the education from Egypt, I mean the staff members from Egypt, and also from the international university. I mean, all the specifications for labs, for software tools, what are the eligibility criteria they will contribute for of course, for the assessment. I mean, the students will be registered as a normal students in the international university, and he will have access to all resources in the university. The only different thing is that the university will be in the venue in Egypt and not in the US or in Japan or in Canada. Okay, so what we have done till now, we've signed our first MOU with Ohio State University, and this photo here is where you can see all the participants, the president of Ohio State University, the Minister of Communication and Information Technology of Egypt, the ambassadors of the United States of America, and the ambassador of Egypt in the United States. And we have also the chair of electrical engineering in Ohio State, responsible for the program, and also our deputy minister, engineer Rafat, signing the MOU. Ohio State University will provide us with the cybersecurity track. This is a new program that is designed by Ohio State with the Center of Cybersecurity and Digital Trust. And the number of students that we are discussing is 100 students per year that we can actually have in one intake, or we can actually have them in two intakes. Our second MOU signed is actually in Canada with the University of Ottawa. And here again, we can see all the members from both sides, from the government side, ambassadors from the university. And our MOU is basically focusing on two tracks. The first track is the AI and data science track, and the second track is about the robotics, the IoT and robotics track. Still in the pipeline, we have a number of universities. We're finalizing with them currently our discussion so that we can actually cover all the tracks. As I mentioned before, we're still looking for the digital arts track for a university that can actually support this track in an innovative and creative way. So this is where we stand now. Our target is to start in the spring 2021, actually in January 11th. And this is with the University of Ohio State. And with the University of Ottawa, most probably will start in summer, in May 2021. Last thing is about partnerships. And as I mentioned, partnership is very important to guarantee the quality of service and the success for this initiative. Partnerships can extend to Egypt Education Institute, different Egyptian universities also, how to collaborate together in this initiative. International companies, international organizations, national companies, government entities are all partners in this initiative. We have 4 collaboration models. First is awareness of state-of-art technology. Second is professional training. Third one is about internships and projects. And the last one is how to connect our students to the market. So these are the 4 collaboration models that we are introducing to our partners and seeking actually their collaboration in one or more of these models. So if you are a multinational company and you would like actually to increase the awareness of our students on your advanced technology fields, you can practically organize some workshops, you can have seminars, you can organize hackathons to our students, and definitely this will be very fruitful in order also to enhance the knowledge and enrich the experience of the students in this initiative. Second one is the certificates. As I mentioned before, you need to have at least 2 certificates to graduate, a maximum of 4. Multinational companies definitely will support this objective with enhancing the students' skills or supporting the certification process. Multinational companies are working in several projects in Egypt, and definitely they can provide some opportunities for or ideas for the projects for the students. They can mentor the students, supervise also the students in this initiative. And finally, they will be part of our advisory board. They can provide the students access to some of their professional networks, and maybe at the end, they can offer them some good job opportunities. So these are the three pillars that the presentation today has touched on: the vision, the program, and the partnerships. And definitely, we can see that the Minister of Communication and Information Technology is looking at DEBI as one of the top training programs in MCIT that contribute in a different way and in a unique way to the students and provide them with a great opportunity to change their lives. By this, I would finalize my presentation, and I would like to thank you very much for taking, I think I took too much time for this, 41 minutes. It's fine. I still have 4 minutes. Thank you very much.
Thank you very much, Prof. Hoda. It's a very interesting presentation. And we have one question from Dr. Sharif Abu Lainin. He wants to ask how are Egyptian university professors are selected for participating in training, giving seminars, etc.
Yeah, well, actually, one of the things that we are doing is we are trying to reach out, of course, to Egyptian university professors, because one of the, policy for this initiative is that we provide actually the CVs of the Egyptian professors to the university, to the international university, to ensure that we are coordinating or synchronizing the international professor with the Egyptian professor, and even the CVs for the TAs. So what we usually do is that we get the CVs, we send them to a committee. The committee is joined between the initiative administration and also the academic team at the international university, and we select which professors are more aligned with the courses that will be provided. So for each track, we have each track and each university. They are not the same. So even if I take, for example, cybersecurity from the University of Korea and cybersecurity from the University of Ohio State, the study plan for Ohio is different than the study plan in Korea. So we have different courses. They are all about cybersecurity, of course, but still they are different in maybe in the content and some of the courses. And we need to ensure that we have the right professor for the right course. Definitely, our email is debi.gov.eg, and even you can send me an email directly on hbaraka@mcit.gov.eg. I will put it maybe on the chat. And I welcome, of course, I welcome. I'm trying to reach out. This is one of the objectives of this session, is that trying to reach out to our Egyptian professors in different universities around Egypt.
Thank you, Professor Hoda, for the answer. I think there is something else on the chat, maybe Dr. Ali Mustafa from the National Institute of Standards, Egypt, but I don't think there is a question. He is just introducing himself. Thank you, Dr. Ali, for the introduction. Professor Gutu and Dr. Samir, do you have any other questions to Dr. Huda? Because I think we are running out of time.
This is Goto. I have a, is okay? I have a
Yes.
question.
Yes,
Okay.
Doctor.
How can the Egyptian university involved in this, the initiative? You know, we have, in EJUST, we have many the professors in area of the IoT or data science areas. And those courses you are talking about is just for the international university in the overseas of Egypt, or can we have this kind of course inside of the Egypt?
Okay, I mean, we have two questions here. The first one is how actually the Egyptian professors can reach out to us.
Yes,
And
yes.
yeah, I think this is, I mean, this is very important. What we are trying to do now, first of all, we are trying to reach to the students. And this, because we have started already the registration process on the 3rd of November. And we actually closed the first round in the 30th of November. So our main goal during November was to reach out to the students, okay? So starting from now, December and January, we will start reaching out to our universities, okay, for students and for the staff. But our main focus for the November month, and actually this one was one of the channels that the IEEE is helping us, is how to increase the awareness for the students, especially that we are reaching to students in all governorates. So in the first round, we had like around 1,000 of students that have submitted their applications. And currently, we are in the final listing of around 200 students ready to go for the TOEFL and Duolingo tests for the first two universities, okay? Currently, our second step in our marketing plan, I mean, well, you can call it marketing or awareness plan, or our reach out plan, is the universities for the staff itself. Because first thing, after we sign the agreement with the international university, they are asking us for the CVs of the Egyptian staff. Okay, so what we have to do is to reach out to different faculties of engineering. And of course, I mean, this is something optional. I mean, we just reach out, and then maybe through the deans of the faculties of engineering, we will have some awareness sessions also for the faculty staff. And accordingly, we will see who are interested in different tracks and get this list of CVs. And then we start the filtration process, and we continue for the selection.
Okay.
Thank
you very much.
Thank you, Dr. Huda. I'm afraid we are running out of time.
Okay.
Professor Ahmed, excuse me, actually, Professor Muhammad Abu Zahid has one question here from EJUST, from this room.
Okay.
Thank you very much, Professor Mona, for the interesting presentation. Professor Huda, for the interesting presentation. In fact, we have a professional degrees in EJUST. I sent the bylaws to you from a week ago. And three of the main topics of the initiative, I mean cybersecurity and IoT and data science. We have a professional master in are 2 years. 2 years period master. How we can come with the initiative? Can we make an MOU between EJUST and the initiative to to cooperate in conducting these three interesting programs?
Definitely, I mean, cooperation is very important, especially with higher education institutions. We need to explore, because the initiative is very much focusing on getting the students out of their life for 1 calendar year. And this is extremely important. These students are fully dedicated for this program, okay? And this is also one of the challenges, because some of the students, especially these students, are very, I mean, they are top-notch students, and they are, they already have job opportunities, and they are already working. So leaving their work for 1 full year, we've seen it's one of our challenges in the admission process.
I couldn't hear you, Professor.
So I think
Professional
Dr.
master
Hoda is
degree.
disconnected for a while.
Sorry?
Dr. Hoda, please continue. Just
Okay.
you have been disconnected for 2 seconds.
All right. So what I'm saying is that this is 1 year program and this is a 2 years program. So we need to see how actually we can support the professional master degrees in EJUST. I think it's extremely important. And we can have, I mean, a session to find out ways of cooperation and to sign an MOU whether EJUST can benefit from the professional master in specific tracks or the opposite side. We definitely are open for this.
In fact, we have a 1 year degree, but it's a diploma degree. It's 20 hours, and we can upgrade the diploma to be a master by adding a graduation project for 4 months. We have 2 types of professional degrees.
We need to have 30 credit hours.
36 for master and 20 for diploma.
Yeah, but this is, I mean, we can look at it, Dr. Muhammad. Let's have a session on this and see how flexible.
I have a second point. The initiative is building up on what the graduates has learned during his first degree. I mean, the students joining the initiative is graduated from Faculty of Engineering or Faculty of Information. What's your opinion about starting programs in the first degree in data science or in cybersecurity as a special programs? Because nowadays we are reforming bylaws for a new faculty. It's the Faculty of Information Technology and Computer Science. And we are planning to add new programs in cybersecurity and data science. Do you think?
Okay, so.
Do you think that this is good for future?
Well, let me tell you something. I mean, I'll just answer this question based on what I have seen during my discussion with several universities around the world. Okay, because we are actually in discussion with more than 15 universities around the world. Actually having even, I'm not talking about an undergraduate certification or degree, but I'm actually even talking about the postgraduate degree. They have just started to have specialized masters in AI, for example, or in data science, and they call it for Master of Electrical and Electrical and Computer Engineering, focus track in AI. So even in international universities, For the postgraduate part, they don't even have this very much specialized. They are just starting to have it at the postgraduate level. So you can see, for example, degrees like Masters of Engineering in Electrical Engineering. And then we are discussing with them, so can you make it focused on this? So we select the courses related to AI and data science, but it is still under the Master of Engineering in Electrical and Computer Engineering. So some of the universities are moving toward the specialization in the postgraduates. In the undergraduate, it's always important to have a general a strong background in some of the courses that are very important for the students in order to be able actually to continue their education at the higher levels. For example, let me tell you something that I have now in front of me, for example, for the University of Ottawa, for the track of AI and data science. One of the prerequisite courses is to have signals and systems. This is a very simple example, okay? And when you look at the bylaws, for example, for the computer science faculties, you may not find at all our computer science faculties this course. They see that this is a prerequisite for AI and data science. So there are some courses that are very fundamental that we need to be very careful when we actually say that we are going to have a very specialized undergraduate faculty or school or program, that we design the program in a way that can help the students actually to continue and to expand a little bit beyond the core courses and to go into much more important applications.
Okay, thank you very much.
Diplomatic answer.
Thank you, Professor Hoda. Thank you, Dr. Abu Zahed. And thank you for all the JAC-ECC organizers. This concludes this session, and see you in other sessions today, inshallah. Thank you.
Thank you very much. Thank you.
Thank you very much.
Thank you. Thank you very much. Bye-bye.
الدكتورة هادية موجودة معنا؟ مش عارف. الدكتور محمود عبد الله. مش مشكلة ممكن يجوين بعدين. نبتدي. Okay, good morning everybody. Welcome Professor Hadia. I am glad to see you today, and I am very grateful to you to chair this session. I am also welcoming Professor Mahmoud Abdallah, the presenter of this interesting topic. The co-chair is Professor Ihab Khalaf, but he is not appear yet. He will join later. But please, Professor Hadia, lead the session. And I ask Professor Mahmoud Abdallah to introduce himself first. Okay. Oh, Dr. Alam, you will introduce Professor Abdallah.
Okay.
Okay, okay. Thank you.
Okay, Professor Ihab, you hear us?
Yes, I am hearing us.
Okay.
I am with you. Sorry for being late.
Welcome, Professor Hadia. Welcome, Professor Ihab. Welcome, Professor Mahmoud. I am Ahmed Allam. I'll be assisting you from EJUST. I guess we can start by Professor Hadia, if you can please introduce Professor Mahmoud.
Okay, thank you very much for your invitation. And as you know, I know Professor Mahmoud very well. We are working together in supervising many masters and PhDs. It is a pleasure to me to introduce him. Dr. Mahmoud Abdallah is working in the Electronic Engineering Department, Military Technical College in Cairo. Actually, he is one of the very active researchers in the field of antenna and propagation in Egypt. He has gained many prizes in this field. The last one was the Shuru prize. His talk will be about the effective trends in international enhancement of multi-input, multi-output antennas. If you have any other questions, Dr. Alam and Dr. Ihab, to Dr. Mahmoud before beginning, it is a pleasure.
Okay. Thank you, Professor Hadia. I guess we can start right away with the talk. I don't have questions from my side. If there is no questions from Professor Ihab, Professor Mahmoud, please go ahead with the talk.
Okay, thank you very much, Professor Alam. Thank you, Professor Hadia, for introducing I have to say that I am one of your students that I'm proud of. I want to share my presentation now and share. So my talk today, as has been said, is about effective trends enhancement for MIMO antennas. I am working in electronic engineering department, the head of electromagnetic waves in Military Technical College in Cairo, Egypt. And in my group, we are working in many research areas of electromagnetic wave applications. The one we are talking about today is enhancement of MIMO antennas. And before I start, I need to acknowledge my contributor, my colleagues who was working with me over the past period, and they have most of this work has been done by them. So the talk agenda today is the introduction for the importance of MIMO from communication point of view, and the requirement for antenna to help the MIMO system to function properly. And then we go to the technique used to the enhancement of the MIMO antennas, starting from the old techniques, the effective ground structure techniques, electromagnetic band gap techniques, using hybrid techniques and current neutralization technique, which is one of the most new one. using meta-surface technique and using complementary configurations and diversity techniques. So since the introduction of MIMO antennas, it has been claimed for enhancing the performance of communication in terms of reducing the error and enhancing the signal-to-noise ratio, maximizing the channel capacity, and reducing the losses. It has been used in different applications, in commercial and defense application, and many mobile application. So also it has been used for wide, large antenna arrays. It has the same design principles. The MIMO antennas used with MIMO systems that we have used is the same number of antennas used in MIMO systems. For example, if you use 4x4 communication system, you have to use 4 antennas. These antennas has to be close to each other in order to function properly. But the challenge here is the mutual coupling that arise between the antenna elements. From MIMO configuration point of view, we need to have good performance, compact structures, and at the same time, we achieve the high isolation between the multiple users so we can make benefit of the antennas. There has been a lot of approaches or trends enhancing the MIMO antenna. However, we have to understand the problem, especially from surface, from microstrip antenna, which is the most commonly antennas in modern communication system. The closer antenna elements we put it close together, that we have a lot of mutual coupling trace between them. This mutual coupling generate currents in the adjacent element, and at the end, the radiation pattern, which is from communication point of view, it is the filtering response of the antenna. It's alerted, and the received signal is different from the transmitted signal. This problem becomes more effective as long as the elements of the antenna are close to each other. One typical solution is to take these antenna elements far away from each other, but of course this will increase the size of the structure, and this is not considered the perfect or the optimum solution. So since the introduction, a lot of techniques have been used. Basically, most of these techniques are firstly thinking at using special filters. Special filters that can be inserted between the antenna elements and then kill the source of the mutual coupling between the antenna elements. Very old technique, what is called defective ground structures, has been proposed first in the last 200 years. So the defective ground structure is one resonance circuit is added in the path of the current. It can be in the ground of the structure or in the top on the structures. It can take many shapes depending on the quality factor required for the filter. From circuit point of view, it acts as a resonance circuit, a tank circuit. So at the resonance frequency or at the operating frequency, this tank circuit can absorb the surface wave and then preventing it from passing from one terminal to one terminal. Antenna element number 1 should be here, and antenna element number 2 should be here. So if we insert any kind of defective structure here, this will be helpful. However, this is all technique as I claimed. But it's successful in preventing the coupling from this one antenna to second antenna in terms of transmission coefficient, which is the first parameter that has been used in the beginning to identify the enhancement of the mutual coupling reduction. So if you believe in the transmission coefficient between the two adjacent antennas, we can find that we can achieve from 5 to 10 dB reduction in the power transmitted from one antenna to second antenna. From a MIMO performance point of view, this reduction in S21 will lead to enhancement of the envelope correction coefficient, which typically should be as close to 0, and from a standard point of view, it would be close to 0.005. From isolation power point of view, there is definition for the envelope correction coefficient that depends on the scattering parameters values. A lot of other parameters from MIMO communication point of view, like the diversity that should be close to 10 dB, on ideal. So the lower value of S21, S12, this lead eventually to the enhancement of MIMO antennas. However, one of these disadvantage from using defective ground structure, number one, it is narrowband structures. Number two, it is causing back radiation, especially if the structures becomes like microstrip configurations. The advantage is very effective for narrowband application. For example, if you use it with array antenna that can be used for radar application, for example, radar application in most cases do not need high isolation, wide bandwidth, but need high isolation. So by using very small isolation slot between the transmitting element and the receiving element, a very huge isolation, less than -30 dB, can be achieved. And if we study the invocation coefficients, that we can find at the operating frequency that these values are very close to the ideal one. Another parameter that if we wanted to consider practically, so this correlation coefficient should be calculated from the reception electromagnetic waves by the other antenna, not only by the isolated port from each other. So there is another definition for the invocation coefficient based on the radiation pattern of the first antenna and the radiation pattern of the second antenna. If we compare the result based on the far field compared with the result compared with the S parameter, we can find that the invocation coefficient of the result obtained from the S parameter is very optimistic compared to the real case of the far field. And there are a lot of standards that identify the minimum threshold for considering this is optimum or good invocation coefficient between the element. These standards give some chances for the invocation coefficient based on the far field to be increased more than 0.1. This format is much preferred, especially if we are using low-cost substrate or low-efficient substrate. If we need to increase the bandwidth of the isolation, so for example, if you have wide band, at the same time, if you need to increase the isolation more than 10 dB, so you have a trade-off between the bandwidth and the quality factor at the same time. One approach is increasing the order of the filter, because as I said before, this is defective ground is simply band stop filter. So if we use more filter cascaded, we can make it like large order band stop filter. This can help for using, instead of one tank circuit, more tank circuits. And if we compare the performance for using one circuit by two circuits, by three circuits, we can find that we can achieve from 5 dB enhancement in the isolation up to 35 dB enhancement, because it's, as I said, it is a kind of cascading filter together. At the same time, we can make use of the cascading system to increase the bandwidth of the operating one. This approach can be at the same time make result enhancement of the return loss. But nothing is free, as everybody knows. So the more defecting ground structure you are using, the more back radiation is happening. So at the end of the day, we may find that we not make use of the isolation, and at the same time we have some disadvantage on the radiation pattern. So the idea of using defective ground structure has been used in limit application, in MIMO applications. So another modern technique is the electromagnetic band gap structure, and the modification of the electromagnetic band gap structure has been continuously nowadays, starting from a high impedance surface going to the new idea of the meta surface structure. As we may know that the electromagnetic band gap structure has been introduced as a high impedance surface in the mid of this century. And from a circuit point of view, it is kind of LC network, but because this L and this C is based on the element of the mushroom structure, which is the first one introduced by Steven Piper in last 50 years. So that can help for providing wide bandwidth and having ignoring the problem of the back radiation of the defective ground structure is an old technique. For example, these elements can be used between two monopole antennas, which is by definitions are wideband antennas, can be designed to serve as ultra wideband antennas from 3 to 10 gigahertz. And we can see that the isolation between these two antennas in terms of the transmission coefficient is order of 30 dB at some frequency, from 20 dB to 30 dB at other frequencies. So if we insert an array of electromagnetic band gap structure and we design these bandwidth elements so that we can control the bandwidth and the quality factor at the same time, we can achieve a wider isolation between the antenna elements using the EPG. However, this is a classical or the traditional electromagnetic band gap structures. Of course, this helps for applications that need ultra-wideband. So if we look at for ECC, either calculated from the isolation, the S-frontal boards or from the radiation pattern board, we can find that it meets the requirement for the standard or the acceptable requirement values for the ECC. It will be less than 0.01 for the ECC values. Again, if we go more deeper in the communication performance analysis, we can find some multiplexing efficiency within all the band is closer to 1. The channel capacity loss on the other side is very low. And of course, this is one approach for using the electromagnetic band gap structure. One of these, the advantage of this electromagnetic band gap structure is the large size. So it basically one layer of one cell of the electromagnetic band gap structures should have a period of lambda over 2 by lambda over 2. So if you decrease this limit, it will not work probably. So over the past 10 years, it has been a lot of open windows for enhancement of the electromagnetic band gap structure, minimizing its size, and at the same time maintaining its good performance for achieving the isolation between the elements. So, for example, if we increasing the order of the electromagnetic band gap structure here by inserting multiple paths in the EPG, so we can use achieve the same performance of the designed EPG unit cell with lambda over 2 by lambda over 2 in typical condition to be much less than this one, and at the same time it achieves the same condition of the surface impedance isolation for the two cells. This is for the conventional EPG structure, and this is for one of modified one, and maintaining the same reflection coefficient requirement. And if we study the performance between one antenna without using EPG and one antenna without using conventional EPG with lambda over 2 by lambda over 2, and the modified one, we can find that the modified one, and this is purple line, can achieve more isolation between the element, and at the same time it reduces the physical size of the EPG structure from lambda over 2 to approximate 0.3. Such enhancement can be used for other type of the EPG structure. This is another configuration of EPG structure was called the uniplanar EPG, which is one of the two basic shapes introduced early for the EPG cells. So if we increase the order of the EPG element itself by using, instead of using air gap capacitance in between, so you're using like interdigital capacitance in between, we can reduce the physical size of such element from 7 by 7 millimeter to 7 by 5 millimeter, which approximately 25% reduction at this time. At the same time, still we have the same functional properties of the uniplanar or the modified uniplanar EBG structure, either from studying the dispersion properties by studying the band gap, achieved band gap, the design band gap for this one, the conventional one, compared with this one, and if from impedance point of view, from achieving very high impedance at the operating frequency. So by using extensive modeling for the equivalent circuit for this one, the dimensions for the elements can be designed and then optimized using electromagnetic simulator. So at the end, we can design a very sharp filters using the same cell and without the need of using multiple or cascaded structures, like the case of the conventional defective ground structures, the old technique, as I said before. And from using the facilities of the electromagnetic simulator feed simulator like CEC of HFSS, for example. So if you excite one antenna from one port and then using these modified EBG structures, the compact size EBG structures, so we can find that very small power can transfer from this one to the port, that port. And from S parameter point of view, we can find that we can S parameter can be reach to up to minus 40 dB. Such performance has no effect on the radiation pattern of the conventional microstep patch antenna, in contrast to the using the multiple defective ground structure, which has result in deformation of the patch antenna. So we still have the typical broadside pattern of the microstep patch antenna, either in two principal planes, the A plane and H plane. And if we study the ECC parameter, we can find that using this element can achieve reduction in the ECC value to much less than the 0.05, which is claimed by the standardization of the communication community. Other approach can be used for the enhancement, modification of the uniplanar EBG. It is still under development by my students. So they include that they make another idea of cooperating two uniplanar cell in one cell. So we can make more wide bandwidth for the uniplanar one compared for the conventional uniplanar structure. This approach can be used to be inserted between the MIMO microstep antennas that can be used as a MIMO antennas or array antennas, making use of the small size of the developed structures. And of course, if we make it this antenna in planar configuration like planar array or planar MIMO configurations, the bilateral configuration in both direction of X and Y can suppress the surface wave in either this direction and that direction. This advantage is not possible by using conventional EBG or by using conventional defective ground structure. Also, this idea can be used as embedded structure between multi-layer structures that is a must for high impedance, high frequencies that suffer from a lot of radiation losses by the feeding network. One solution for this one is isolate the radiation, the feeding network from the radiating elements. The problem is the more frequency we have, the higher frequency we have, that we have more difficulty in the dimension of the modified EBG structure, which will result at the end with limits on the fabrication or the available fabrication in Egypt or in any conditions at the price cost for the fabrication either in Egypt or outside Egypt. So we have concluded that this approach has a limit of about 18 gigahertz and cannot be functioning economically efficient for frequency higher than 18 gigahertz, and this is why we introduce in the next part of my talk it's a new type of isolation technique. One approach for the designing the isolation technique using the advantage on the defective ground, which is a simple structure and the high quality factor can be designed, and the wide band of the electromagnetic band gap structure. So one approach is making hybrid techniques between the defective ground structure and the electromagnetic band gap structures. Between the elements of array antenna, the spacing is much convenient to suit for electromagnetic band gap structure or small side of electromagnetic band gap structure. However, if you're gonna use this element as an array in radar application, for example, or transmit receive applications, so the spacing between the transmitting and receiving element becomes more more critical. So in this hybrid configuration, we suggested that we use EPG, small size EPG element between radiating element in MIMO configuration or array configurations, making use that we have fair enough distance between that element in terms of half wavelength condition. It helps in modification the radiation pattern of each cell, especially for low-cost antennas that make use of low-cost substrate like FR4. So it helps for enhancement the gain and enhancing radiation, the main radiation pattern of the array configuration. And at the same time, this is of course because reducing the transmission coefficient between antenna number 1 to antenna number 2, which is the most bad scenario that could affect it. So if we can reduce the power from 1 to 2, so definitely we can reduce the power transfer from 1 to 4 and from 1 to not adjacent element. Still, the other problem that if you're gonna use, because this application was presented as a hybrid transmit receive hybrid isolation antenna array. So if we use these configurations, we avoided using EPG structure between transmitting array and receiving array. So instead of this, we're using a simple defective ground structure, and we haven't used any high order defective ground structure to avoid the deformation of the radiation pattern. This helps in reducing the compact size from the whole transmit receive array from this point to this point, and at the same time achieving a very high performance in terms of the radiation pattern and preventing the feeding antenna to transmitting antenna from passing to the receiving antenna. These all three techniques include the use of some isolation techniques between the transmitting antenna or the receiving antenna or the two adjacent antenna in MIMO configurations. One recent technique has been raised and developed by my team is based on avoid using any isolation technique between the transmitting element and the receiving element or the two MIMO antenna elements, and making use of the making current neutralization technique between the elements. This help in the making the structure is more simple. We tested these structures for small antennas because we have concluded that such idea is very efficient for small antennas. Other than large antenna, it becomes more or less complex. So we designed this for metamaterial antenna or composite right left-hand antenna that is very small antenna by definitions, and we designed this configuration antenna such that it looks mirror to each other. For example, this one is based on interdigital capacitor and loaded with the stub acting as an inductor, and this is capacitor, so it is composite right left-handed configurations. This antenna number 1 and this antenna number 2, assuming feeding from this port, induced current is induced in the other antenna. At the same time, if you excite this antenna, induced current will be induced in this antenna. So we investigate these two antennas for two different scenarios. The first one, this antenna is mirror for that antenna, and in the other comparison case, this antenna is the same like this antenna. And we compare between the induced current in the second antenna compared to excited current. So for example, if we excite the antenna at this port and look for the current induced in this direction, we can find this current is oppositely to the excited current to the antenna number 2. On the other side, if we compare this structure, if we excite one antenna in this by antenna number 1, we can find this current is the same direction of this current. So without using capacitor mirror or without using mirror or the current, we couldn't achieve what we call it current neutralization, or effects that cancel each other. From experimental point of view, we studied the isolations between these two configurations. We found that when you use the mirror configuration, we can achieve more reduction in S21 configuration. And of course, this enhances the MIMO configuration in terms of the envelope correction coefficient and diversity gain and the total absorption. We make this approach is more generic, and we use it for one balanced configuration, so that we make sure that our conclusion is not suitable, is not limited to one configuration and not suitable for the other configuration. So we designed one balanced configuration for one antenna and make mirror for the other configuration and compare it with one antenna and without mirror in the other antenna. And we studied the current configuration for the mirror one, the one we suggested as a current neutralization technique method, and the one without current mirror, and the one with it has a current distribution method. And we find the same conclusion that these two current are adding to each other, which is at the same time it deforms the radiation pattern. From scattering point of view, if you compare the one with current neutralization technique with the mirror configuration with the S21 of the one of the non mirror configuration that has no current neutralization technique, we can find that we can achieve about more than 5 or 7 dB reduction in the S21, reaching 30 dB with very, very small distance in between, that is no more or less than 1.8 millimeter. This level of isolation between these two radiating elements has been achieved without the need of using any element in between the two elements. And I have to say that this technique has been suggested successfully with a small antenna, not with all types of the antennas. From MIMO configurations, this is the second reversal current configuration still has a good envelope correction coefficient at the operating frequency, and the good diversity gain at close to 10 dB at the same operating frequency. Of course, this can be also confirmed for the last time by reversing the stuff in this 3 direction to achieve more reduction in the current that can reach to close to 45 dB or 50 dB. These techniques has been designed also for avoiding using the metamaterial configuration, and we're using what's called negative mu configurations. That's based on loading the one hosting transmission line instead of series capacitive load and shunt inductive load that's common for right left-handed configuration, but for loading only the series capacitive load, which is in terms of the interdigital capacity, and reducing removing the inductive load. This is called negative mu configuration. This is a kind of metamaterial structure, not essentially a composite right left-handed structure, and has been suggested in the past couple of years as one approach for small size antennas that can be used for single band antennas or zeros order antennas, not multi-band antennas. So if we study this configuration and we make use of the same idea of the current neutralization, the same successive result has been achieved. In one of the most successful approaches has been presented, has gained a lot of citation still so far this year, is to make use of the hybrid ideas, is to making one reversal current configuration between one antenna and second antenna, and using a small deflecting ground structure in between the two antennas with very small size, with less than 1.8 millimeter. And amazingly, we could achieve reduction in the S21 that is very close to 45 minus 45 dB at the operating frequency. Of course, this very reduction comes because the hybrid configuration between these two antennas. One of them is the defective ground structure, and another is the current neutralization technique. So we make use of the compact structure and the high isolation between the two elements. As I said before, early in my talks, that the use of defective ground structures, the use of electromagnetic band gap structures will have a problem or limitation as the frequency is increasing. Because as the frequency is increasing, the design of EBG structure or defective ground structure requires small size dimensions. And this eventually will require a very complex fabrication technique, maybe not available at low cost in Egypt. So we have suggested that if we go to high frequencies,
Professor Mahmoud, we have about maybe if we can wrap up in 5 minutes, around 5 minutes, please, to allow for Q&A.
Okay. I'm almost finished.
Okay, thank you very much.
Okay, I'm almost finished. So by using this configuration, we can go up to 28 gigahertz, and keeping the advantage of fabricating. This other technique is complementary techniques that is using the mirror techniques can be used also for the wide band antenna. So if we use one antenna and another antenna in reverse configuration, we can achieve a very wide band. And from application point of view, this is succeeded in achieving have been tested in environment configurations. This is another one. This is complementary structure for these complementary structures. This is one idea. I'm sorry, I'm trying to go forward. And this can be used for the massive configuration, because at the massive configuration of MIMO, we don't have the luxury of inserting structure in between the elements. The most successful properties has been designed in the MIMO antennas is to make use of all the other techniques. We cannot say that is one successful and another is not successful structures. So our conclusion from my recommendation that we make use of using electromagnetic band gap structure, for example, in addition to reversing the configuration of the antennas, can achieve in very small size of the antenna elements, achieve the required configurations. So the conclusion of my talk here is there's a lot of hybrid techniques has been designed and evaluated every day for MIMO antennas, and the coming future or the coming successful approach is the using of the hybrid diversity technique. So for example, we can use a hybrid diversity between polarization technique using defective ground structure techniques with EBG techniques, and this is a conclusion for my talk today. Is we have a lot of trends or approaches for achieving good trends, good performance of MIMO antennas, and at the same time, these all techniques are helping each other. They conclude my talk, and thank you very much, and I'm ready to hear questions.
Thank you, Professor Mahmoud, and we are ready for questions. So if there are questions from the chairs, please, Professor Hadia and Professor Ihab, if there are any, please go ahead.
Yeah. Please, Dr. Mahmoud, the technique of increasing the quality factor of the defective ground structure by slots, more slots, do you think that this will decrease the bandwidth of the structure? And if we try to use the technique of wideband filters, which is a maximum flat or polynomial structures, this will increase the bandwidth. What do you think about it?
I agree with you. Actually, I present this structure. We have this approach not for proving that it's successful, but to saying that is limited in the bandwidth and it is limited in the effect on the radiation pattern. So I'm just introducing as a kind of comparing sides. I'm not saying that is using multi. Yeah, I agree with you.
Okay, thank you. Another question, if I have time. What do you think about the terahertz band? We are now working in 5G technology, and then it will be in tera. Is this techniques will succeed in this band?
We haven't worked in the terahertz band, but we have some simulation technique for the sub-millimetric band at 300 gigahertz. Not we can say that at the beginning of the terahertz. So for this technique, we in my work with my students, we have been used the meta-surface techniques, because the meta-surface technique allows us to using not very small dimension and at the same time satisfies the requirement. So this is from our experience at only for 300 gigahertz, which can be considered for the opening or the starting of the terahertz.
Terahertz, yeah.
Yes.
Oh, thank you, Dr. Mahmoud.
Thank you.
Any other questions?
Any other questions, please?
Yes, Dr. Mahmoud, I have with you.
Yes,
I have very little questions about actually when you are designing multi-element array. Always the isolation not at the same frequency when the return loss or reflection coefficient is better. Do you think from where comes this problem? Is it clear my question?
No, I didn't. No, I didn't get it. You mean that in case of array antenna like this one?
Yes, like this one. For example, this one, but this one actually the isolation is good at the same frequency when the reflection coefficient is good also. But you have another curve. There is a shift in frequency. We are designing actually some design like this, but always when we are trying to enhance the isolation, not comes the best isolation at the same frequency where the reflection.
I get your point. I get your point. Basically, this one trick for the isolation is there is a trade-off between enhancing the isolation and being low return loss. So if you get low S21, you get high S11. This is cannot called enhancement of isolation. This is like changing the power from being matched to be transferred to the other side and vice versa. But if we design the isolation technique carefully, whatever the types, EBG or defective ground or meta-surface or whatever, we should have a reduction in the both together, like this case.
Yes.
Like this case, for example. This case, we have good matching at the same time S21 is reduced. So this reduction S21 is not at the expense of the of S11, but this is due to the killing of the surface wave. And this is the optimum design. Sometimes we cannot, because we cannot kill the surface wave perfectly, so we can find that you have a trade-off between matching. But at any condition, we cannot claim that S21 is reduced and at the same time S11 is increased, and this is mutual coupling enhancement. This is not good. But in order to achieve this, what I'm trying to say is that you should not avoid using the low-cost substrates like FR4. You should design stable frequency, high frequency laminations, and this is from the experience we gain. We can discuss it in deep, if you like.
Okay, sure. Thank you very much.
Okay, thank you. We have one question from Professor Abdurrahman.
Thank you, Professor Mahmoud, for this interesting presentation.
And I would like to thank you and your team for this huge amount of contribution to the field of antenna. Actually, I am asking about the effect of miniaturization to the antenna performance.
There is one kind known probability. This is the smaller antenna size, the smaller the gain. There is a fundamental limit of the miniaturization of the antenna. It is not open. So when you make the miniaturization of antenna, we should not avoid these fundamental limits. It is explained theoretically in the literatures. If we go behind this limit, we lose the gain and you lose the efficiency of the antenna, and maybe this is not antenna rather than resonating structures. So this is this one thing we have learned from mistakes in my students. Sometimes they do very small antenna, and when we measure it, there is no gain at all. So this is very good questions, actually, especially when we are dealing with small size antenna like metamaterial antenna. We should be very careful that we are still designing in the dispersion diagram. We have radiated wave rather than resonating structures.
Thank you.
This is my answer for you, Professor Ali.
Thank you. Thank you very much. Thank you. Any other questions? Is there a question? Okay, so we have a raised hand. So, Professor Fathi
from Zagazig.
Zagazig University. Please go ahead, Professor Fathi.
Yes, thanks. Thanks for all. For the last questions, Dr. Mahmoud, it is glad to hear from you and from your area. But this is not my area of research. But what about of etching process effect on the behavior of antennas?
Yeah. The fabrication process itself, whatever it is, lithographic technology or the CNC technology, is not ideal. So this all the etching process or the lithographic or the in any kind of this limitation of the imperfection in the fabrication process will definitely affect the antenna. There is one token, one token. Our idea that is we will be lucky if we get good measurement in the first trials. If the experience for the professor are dealing in antenna, as we learned it from our teachers, from our leaders, that we should be careful for the fabrication, and we have to expect what will be effect on the measurement, especially if the antenna size is small. So for small size antenna, for example, for these antennas, you see the separation between these two elements is less than 2 millimeters. So we have to fabricate it in very precise lab, or to avoid this challenge of this one. Of course, we are limited here in Egypt for the available fabrication techniques, but the beauty of the antenna electromagnetic designers that we have more degree of freedom to avoid such problems. So I agree with you. The etching is affecting the antenna performance, especially for the small antenna size, and we should play around.
Okay, thanks for it.
Okay.
Thank you, Professor Fathi. It seems there are no other questions from the audience, and actually we run out of time. So I'd like to conclude by thanking Professor Mahmoud for the very interesting talk, and thanking the chairs, Professor Hadia and Professor Ihab, for their contribution and their time. Thank you very much, and we close this talk.
Thank you, Dr. Ahmed. Thank you, Dr. Mahmoud, very much for your talk. It's a very interesting one.
Thank you, Professor Ahmed. Thank you, Professor Hadia, and thank you, Professor Ihab, for this talk today, and thank you for all the audience.
Thank you very much, Dr. Mahmoud, for a very interesting talk. And thank you, Dr. Hadia. It's nice to see you. see you.
Thank you very much, Dr. Ihab.
Thank you.
Thank you all. I think we finished the first part of this of today. We have a coffee break now. I think we exceed 15 minutes from the coffee break, but we will start our next part at 12, exactly 12. We will have two rooms. The first room, virtual room 1, will have the workshop, next generation networks in smart cities. And then virtual room 2, it will have the technical session 2, selected topics in circuits and systems. So if you are a presenter for the technical session 5, please go to room 2, virtual room 2, the link in the program. And if you would like to keep with us for the workshop, you stay in this room. Just at 12, we will start at 12. We have around 10 minutes break. Thank you all. Dr. Hisham, are you with us? المفروض ان هو كده سلم هو خلاص. هو ده السبيكر. يس.
هو كده مقفول. طيب والسبيكر ماشي. تسعة فلور واحد. بالظبط. كتبت شوية ايوه. تبعت الامتحان. الحمد لله. والار سي اس بس انا بعت للجنرال السؤال كلهم ما عملش. وانا كده يعني انا بقى ميوت ولا لا انا كنت ميوت.
Professor Motta?
Yes. Do you hear my voice?
Yes, but it is in Japanese, so I cannot read.
I'm sorry. I have no way to change it. Thank you very much. Yeah, I have to change.
Next time, I will try my best to figure out.
Okay.
Thank you. Okay, I think Professor Hisham is here also. Professor Hisham, our share session. And Professor Seliman Wu, I think Professor Seliman?
Yes, I'm here. Yeah.
Yes. Okay, we have 4 minutes to start. So if you would like to try your screen, to sharing your screen and make sure everything is okay, you can start now. Okay.
Okay.
I leave the floor to Professor Rami Zwail to lead this session from EJUST.
Professor Wu,
Can you hear me?
Yes, yes. Well,
Hi.
yeah.
Hi. How are you?
Hi.
I'm
Good. Thanks.
Hi. Nice meeting you. My name is Dr. Rami Zuel from eJust here. I'll be co-sharing on the workshop with Professor Hisham Badawi and Professor Usama Muta. And I believe both are here with us.
Thanks for inviting. Yeah. Thanks.
And
nice work.
I'm gonna start with the introduction, and you can start with sharing your screen right after. So
okay.
We would like to welcome you in this workshop under the title of Next Generation Wireless Network in Smart Cities, presented by Professor Wu. Professor Wu received a master's from Peking Institute of Technology and a PhD from University of Electrocommunication, Tokyo, Japan. He's currently an associate professor at the same university, and his research interests include edge computing, IoT, and intelligent transport system. And with that, I'm going to leave the floor to Professor Wu to start his workshop. Thank you very much.
Thanks. Thanks a lot for the introduction and inviting me to this workshop. It's my pleasure. Okay, today I would like to talk about collaborative intelligence for Internet of Vehicles. Okay. Is it okay? Okay. Then the outline would be like this. First, I will introduce a little bit about the background, specifically the IOV and the challenges, and then explain what is collaborative intelligence and its relationship with the IOV. And then I will go through the 3 layers of IOV, which is the perception, networking, and computing and the systems. And then finally, I will conclude my talk. Okay, first, actually, I think most of the audience will know what is IOV, and actually, there are many interesting applications anticipated in this kind of scenarios. IOVs, for example, like platooning, autonomous driving, intelligent transport systems, and many more. And actually, the same with the IoT. The IOV layer can be classified into 3 aspects, which is first, perception. The perception layer means that we have to know, okay, any
can you hear us? Good?
I can hear, yeah.
Yeah, okay, that's good, okay. Thank you.
Okay, any problem with my voice or something? Okay.
No, I can see you clearly now.
Okay, that's good, then I will continue. Okay.
Yeah, thank you.
The first perception layer. Perception layer is the action about the perceiving the environment. So first we have, before doing some actions, we have to first know the environment, right? So this is the perception. So the challenges here is that the traditional sensing technologies cannot satisfy the requirement of the perception of a complex environment, because especially for the autonomous driving scenarios, the environment itself is very complex. For example, even we have many types of sensors, for example, camera, LiDAR, radar, something more, but it's quite difficult to really understand the environment. So we have to have many different types of sensors, and then we have to achieve collaboration between different multiple vehicles. For example, a single vehicle can perceive something, but that's not all. So we have to do some kind of collaborative sensing. That's actually, I think, the future work, one of the important future works. So the next one is the networking layer. So networking layer mainly does the communications between among different entities. So in this layer, the challenge would be how to achieve an efficient communication in a highly mobile environment. that's quite challenging because vehicles are moving on the road. So that would make the communication very challenging. So for the application layer, which is the top layer of this security layer, and the application layer mainly has some kind of challenges for the computing because we have very big data. So we have to compute this data. Sometimes we have to compute it in a very real time. So that's very challenging. And another one is in order to shorten the delay, some kind of like edge computing technologies are currently used for some scenarios, but we have to make sure the efficient collaboration between the edge and the cloud, because the computing power of the edge is very limited. So we have to make an efficient collaboration between edge and the cloud. That's also very challenging technical issue. Then I first introduce a little bit about the importance of IOA by using my experience. This experiment is actually we have done in several years ago, but I just put it here just in order to explain some kind of importance of car data collection. For example, we did this in several years ago for collecting the car data to the cloud, to our server. So the scenario is like this: the car race, in the middle of car race, the race car race is the name of the car race is Super GT, which is very famous in Asia, which is sometimes it's basically held in Japan or some kind of in other Asian countries. So this is very famous in Asia, and actually we wanted to collect this car data in the middle of this, but of course one of the choices would be like use cellular communications to collect the car data. Car data means here like RPM, gear position, speed limit, this speed shift, this kind of information. Of course, GPS is one of the car data. So we want to collect this information in the middle of car race. So how to do this? The one option would be use cellular communication. But unfortunately, we cannot do that because we failed to do that because basically the car race is happening in a very rural area. So that means that this cellular operator doesn't expect too much user at the same time. So when there is a car race is happening, so many users will go there, and then each person can the bandwidth allocated for each single person is very limited. So that the bandwidth is not very limited, so we cannot collect the data as we anticipated. So another approach is to use some kind of decentralized communication, or maybe we can say that free communications, something like Wi-Fi. So Wi-Fi is sometimes good, but Wi-Fi only can collect the information when the car change tires in the pit stop, right? So thus we consider the collection of this car data at the pit stop, but the problem is Wi-Fi doesn't work very well. I mean, the Wi-Fi means the original infrastructure-based Wi-Fi. So there is a Wi-Fi router, and then car connects to the Wi-Fi router. This way doesn't work well because every time the vehicle will stop at a very different place. So even you can change the location of Wi-Fi router, but it doesn't get you a very good result. So I want to say here is like we have to get some kind of very flexible protocol. Flexible means we may automatically select some route. So we put some a forwarder randomly, and they select the best route, and then we know that by using this kind of very efficient route selection, we can get very much better performance. This is just want to show you that sometimes we have to do some kind of improvement on the communication. So then I explain a little bit about the collaborative intelligence. So what is collaborative intelligence? So first, collaborative intelligence means it's based on communication and computing, of course. So collaborative communication is not a new topic because we have been using these kind of collaborative communications. For example, like Wi-Fi is actually like collaborative. And all devices will contend for the same wireless medium, and they using a collaborative approach, which is actually random approach to select the backup time. This can be seen as a collaborative, but here I say collaborative in a very more advanced collaborative approach. For example, like the current research trend is going to the learning. So collaborative learning means like federated learning. So I will explain this later. Federated learning is one kind of collaborative, one approach to achieve the collaborative intelligence. And also another thing I want to mention in this talk is computational intelligence. So computational intelligence includes the neural networks and the fuzzy logic. Especially in this talk, I will talk a little bit about the fuzzy logic and the neural networks, because these two approaches are actually, I've been using very, I've been using this approach to solve a lot of problems in my previous work. But then first, federated learning. So what is federated learning? So for example, let's see this scenario. Let's see first the right bottom, this scenario, street scenario. And then we can see if we are driving in the urban area, our car is learning by itself, but this car cannot learn the environment in this kind of mountain area. So once these cars go to the mountain area, this car cannot do a very good decision because there is no experience for this car. So how to do this? How about we exchange the experience between cars, among cars? So how to do this? We want to exchange the information, but we want to protect the privacy. That's the very important issue, privacy, right? So in here, we cannot send all the raw data, for example, camera data to other vehicles because we are, some kind of, concern on our privacy. This is one. Another one is sending all the raw data to another car, even to the cloud, is not realistic because that will consume a lot of bandwidth. That's unrealistic, right? So how about we learn something at local and then exchange with other vehicles, only our learned information. So this is federated learning. So every vehicle will learn something based on its own experience, but there will be a model generated after the learning. Then all the vehicles exchange their learned information. That is the model. That is not the real data. That is model. So then the central server will aggregate all the models from all the vehicles and then get a global model. Then disseminate this model to all the vehicles. Then all the vehicles will have knowledge about all the environment. That is the federated learning. This is a very, new research area in terms of, the machine learning, also in terms of application of machine learning. So if you are interested in this idea or something, how to apply federated learning in IOV, then you can go through the paper shown here. It is our paper published in this year, in May. And this is federated learning. Another one is fuzzy logic. So I mentioned fuzzy logic here because I have been using fuzzy logic techniques to solve many problems, because the strongest part of fuzzy logic is that it can express the very complex environment using very simple rules. For example, for solving a real-world problem, there would be like two main approaches. The first one is use mathematical formulas to solve this one, so to optimize the problem. This is one approach. The other one approach is like using heuristic, and where like fuzzy logic is something kind of like heuristic, or maybe you can say like that is not mathematical approach. So this belongs to the computational intelligence. So fuzzy logic, for example, what is fuzzy logic? Let's see. In here we can say that For example, let's say a signal strength is good, a byte, or a medium. So sometimes we will have some kind of signal strength indicator value, right? So if I'm not an expert, I see the exact value of the RSSI indicator, then I will not know what does this mean. So, but fuzzy logic will tell you, like, for example, this one is 0.7 here, then the drawer vertical line, and we will know that its byte is 0.5 and the medium is 0.5. That means 0.7 is like either is half byte, half medium, something like that. So it is just an example. That's an example, right? So the fuzzy logic means like using linguistic variables to express the fact. But basically, we know that computer uses the numerical value, right? Exact value. But fuzzy logic uses the linguistic variables. Linguistic variables, human uses actually linguistic variables, right? So the fuzzy logic, the reasoning of fuzzy logic is very similar to human reasoning. That's the strongest part of the fuzzy logic. And another one is neural networks. I think most audience will know about this. And then I will go through the layers of the IOA and talk a little bit about the challenges for each layer. Then first, perception. So as I mentioned a little bit before, like perception is a very important and the very first step for before doing the correct decision. So first we have many kind of sensors, for example, radar, camera, and other sensors, or of course include LiDAR, something many more. So first we have to do some sensor fusion, right? We have to collect sensor information from different types of sensors. This is sensor fusion. Another one is only single vehicle perception is not enough. So we have to do some collaborative sensing. For example, as shown in this paper, this slide, let's see that the right vehicle could be the cluster height, and then collect some information from another 3 vehicles, and then do some, aggregation here. In this case, the right vehicle can do much better perception of the environment, because sometimes each camera can see is very limited. But if we combine different cameras from different vehicles, what we can do is much, better than the single vehicle. So this is the kind of, one of the important future work, and also the very hot topic in the perception. If you are interested in some detailed discussion on the details of this perception, you can see this paper. We also mentioned some recent works on the perception in IOV in this paper as well. And for the networking, like we will know that there are many types of communications are available in the IOV for the IoV vehicles, right? For example, cellular is the main approach. For example, cellular V2X, and also 11P is is also another one, and of course like millimeter wave, something like that. So these all make a multi-access environment, right? So multiple types of communications are available at the same time. So we have to choose the best one and then make the balance between these. For example, as shown in this figure, we can know that this is the top, the cellular base station, and we will know that if all the single vehicle will go through all the vehicles go through the base station, then the cellular bandwidth will not, will become not enough, right? So in this case, we have to do some kind of, balance. For example, if some vehicles are requesting the same content, we can do some caching on some vehicles. This vehicle can work as edge vehicle, right? For example, here, if these 3 right vehicles are requesting the same content, then this vehicle can be the edge vehicle and then download the data from the base station and then do some caching here, and then distribute the content to all these 3 vehicles. This is a very common approach for caching. It's similar. this networking. And also for the V2X communication, we have for the decentralized communication, V2X communication, V2V communication, especially we can see we have two different types of communications in terms of the networking layer. Like for example, first one is broadcast communication. For example, like right-hand side top here, we can see some extent happen, and then we have to disseminate this extent information to the upcoming vehicles. Then this is broadcast, right? This belongs to the broadcast communication. Then another one is the typical like data collection or data downloading application for the vehicles. And this is called unicast communication. So of course the challenges is quite a little bit different, but the same thing is that we have to consider protocol overhead for all these those applications, right? So for the broadcast application, then one challenge would be end-to-end delay, because this broadcast application belongs to the safety application. So that requires a very short delay. So for the unicast communications, maybe the cross-layer performance is more important, because we actually are using some, for the data collection, we are using TCP. So we know that the performance TCP is dependent on all the lower layers and also TCP protocol itself. So the cross-layer performance would be very important in this case. So also some challenges. I want to mention spatial temporal challenges. So spatial challenges means the high mobility, sparse connectivity, and the high density, or maybe some kind of disaster is spatial challenges. And also temporal challenges means like the environment itself is changing with the time. That is temporal challenges. And of course, there is also some kind of, we can use this kind of temporal difference, and of course, using this kind of big data to some kind of utilize this temporal relationship. For example, we can predict the future vehicle density based on the previous, based on the history data, right? So that is also one kind of challenge, also another kind of good thing for us to utilize. So another one is, of course, these two challenges may occur at the same time. So first, how to solve the spatial challenges. First, mobility, how to solve the mobility, how to solve the sparse network problem. Of course, these challenges have been discussed very extensively, and many papers have been published to solve the mobility issue, some other issues. And also we have published some in here. And our approach is to use edge computing. Edge computing here means like we use some vehicles as edge nodes to do some, caching on the vehicles. This is our approach to solve some kind of problems. And then another one is for solving the high density problems. We have proposed one approach, which is like actually the right-hand side of the figure. This is our approach. The left-hand side is the conventional one. So let's first see the conventional one. Left-hand side. This here, S1 to S2 to Sn is the source node. So S1 denotes for the source node 1, and S2 means the source node 2, and Sn means the source node for the traffic number n. And so D1 to D2 to Dn are the destination node, the corresponding destination node for, let's say, S1 is sending data to D1. So for the conventional approach, maybe S1 is sending to F11, and then send F11 is sending to F12, and then finally go to the D1. So the conventional one would be like this. And in here, the problem is too many forwarders in the area, right? This is of course, it is the worst scenario. So how about we do it like this one? Do it like right figure. It means that we actually using the same forwarder node for all the traffics. So this is possible in vehicular network because the route, width is actually very limited. as compared with transmission links, right? So we can do this kind of communication in the vehicular networks. So how about doing it like this? The good thing here is like if we do like this, we can actually reduce the number of senders. So that's good for a micro contention. And for the details, how much we can achieve, we did some theoretical analysis and also simulations in this paper. If you are interested in, you can see this, go through this paper. And then another one is the vehicle to roadside communications. This is basically saying the unicast communications. And then the challenges would be like mobility, of course, and the route length. For example, we are using some way-to-way, and then way-to-R. We have to, find the best route, right? So another one is micro contention issue. Is like this. If we choose like routes like this, then we will have very big problem for the micro contention because too many nodes will be contending for the same channel. That means like the contention efficiency would be very bad. So of course, another one is TCP performance. For example, all the communication we are using currently, for example, internet connection is actually multi-hop communication. So even sometimes the multi-hop means like multiple wired hop, or maybe sometimes it's wireless hop, right? So especially for the wireless hop, the TCP performance will drop drastically with the increase of the number of hops. So how to solve this? That is another problem. So our solution would be like, first we find the best route, and we also improve the micro contention issue, and also we do some kind of upper layer, tuning issue. So for the details, first, we want to do like this, like the right-hand figure like this. We want to do like this, and then how to do this? First, we use fuzzy logic to solve the problem. And actually, this is where it's kind of, first, we consider three factors, which is distance, mobility, and the RSSI factor. Because this distance means inter-vehicle distance, and the mobility means the mobility, right? RSSI means signal strength. So let's say the distance is, of course, important. If we choose the very short distance node as the next hop, then the efficiency would be bad. But if you choose a node with a very long distance, that will have a problem of the signal strength, right? So basically distance and the signal strength would be a contradictory way. So how to efficiently consider these three together, jointly consider these three, that's a very difficult problem. So we use fuzzy logic to solve this problem. Because of the time limitation, I would skip some of the details. And then first we define these three factors and they use fuzzy logic to combine these three factors to get a fuzzy value, and then using predefined membership functions to convert a fuzzy value to a numerical value. Because finally, we have to use numerical value by comparing this numerical value to define which one would be the best next hop. Here we are seeing that the route selection problem. So this is the details of the three factors: mobility factor, and also this is as I mentioned this as in a paper like leadership factor. This is related to the vehicle distribution, and this is related to the signal quality. So I have to skip the details, but just want to mention here that for the fuzzy logic, all these membership functions mentioned here, and also output membership functions are all defined based on the experts' knowledge. So but it's very easy to define. For example, very easy to define. So with a very easy definition of some kind of rules and some kind of membership functions, fuzzy logic can do a very complex reasoning. That is the good thing for the fuzzy logic. So this is the defuzzification value. So because I would like to skip the detail. If you are interested in, you can go through the, this paper. All the details are written in this paper. Okay, for example, last step is for example, by using this fuzzy logic, we will get a final fuzzy value, which is like perfect 0.5, good 0.5, acceptable 0.25, like this. So this is the fuzzy value. So how to convert this to a numerical value? So we have to first have an output membership function. This is the output membership function. And this membership function with this fuzzy value, then we'll have a this shape. And then the center of this shape will have a point, center point, right? So for example, center point is here, and then we'll draw a vertical line, and then we'll get we can get a x value for the x-axis. So that would be the final numerical value. Anyway, you just want to know that by using this output membership function under this fuzzy value, we can get a final numerical value. That numerical value is used to whatever you want to do. For example, in this case, which is used to the next hop selection. And for the route selection, we also use kind of a learning approach to improve the route based on the exchange of beacon messages between vehicles. Specifically we use Q-learning to update all the route tables like this. For example, then RSU is right hand side here. RSU will send hello periodically, and all the vehicle will send hello message, which is beacon message. Send these beacon messages periodically. So for each hello interval, every vehicle can get some information from the neighbors. Then based on this information, this vehicle will somehow know the things happening in the neighborhood, and then this information will be delivered to the two hops, right? But with little delay. That's Q-learning, of course. So that that is actually basic nature of the Q-learning. That's delete reward, right? So we use delay. We use delay Q-learning in it here. Okay. Then for the TCP side, actually I just mentioned that TCP has a very big problem for the long hop transmission of data. So especially for the wireless part, for example, let's say vehicle one is sending some data to vehicle one. So the data could be lost at any hop. So for example, if the data lost at here, then the data will be retransmitted from the source node. That is really inefficient. So how to solve this kind of problem? And of course, when there is a packet loss happens, the TCP will reduce the congestion window size. That means the reduction of the throughput. So we have to improve the throughput, right? So what we have done is we split the multi-hop TCP to multiple one-hop TCP and do some kind of course, some kind of tuning to make the long-hop TCP transmission more efficient. So for the simulation, just do the very simple simulations here. This is for the two-hop communications, and here one is collaborative and the other one is not collaborative, not non-cooperative. For example, this is for the delay. If we use non-cooperative approach, then the delay will increase with the number of CPR, the number of traffic flows. CPR means constant bit rate. So our approach can get very a stable delay for this scenario. And the delivery ratio like this, our approach can get a very stable throughput, while the conventional approach would face some packet drops in the reduction of PBR with the increase of the CPR flows. And this one is for the collided mic frames. Actually, this is very related to this delay. Actually, the reason for the delays is because of the inefficient mic layer contention. So the collided mic frame, number of collided mic frames increases means like there are many collisions among the packets. So that's the best thing. So what we improve is like improve this kind of contention efficiency. Then we will have a smaller number of collided mic frames, and then finally go to this. The result is much lower delay as compared with the conventional approach. Okay, then throughput is for the unicast communication. For the throughput for the TCP, then we will have a very significant improvement over the existing approaches. And this is for the freeway scenario. We can see the similar trend in the similar improvement on the street scenario. Then for the resource allocation, this is what I mentioned before, is like only the route selection, but the communication and the resource allocation is not only like this. We have many different kind of, this is route selection is only one of the important problem, only one, right? So we have many different types of problems. For example, how to allocate the computing communication resources. For example, how to jointly allocate or something like that. For example, very complex environment, how to allocate the resource blocks or something like that, similar approach. So basically the current trend is shifting from the reinforcement learning to deep reinforcement learning. So that's why, because the reinforcement learning, the well-used reinforcement learning approach is Q-learning. So basically Q-learning represent the state as table, so two-dimensional data. So that is that is really simple, but what it can express is very limited. For example, very complex environment cannot be expressed by the very simple two-dimensional data, or maybe very simple table, or maybe even if you can express that, you can use Q table to show the state, but that table will be very big, too big to solve. So that's why of course, that's why the basic trend is using deep reinforcement learning to solve this problem. Now, of course, we have done many things in many studies in this area. You can see the details here. And for the finally computing and the systems, we have some problems. For example, like task uploading, caching, edge computing, and of course, many sensors. We have to result in a very big data. So how to solve this big data? That is a very important problem for this. So of course, one important research topic is also lies in the collaborative task uploading. How to collaboratively solving a very big task, for example, like shown in this figure. And if you are interested in the details of the collaborative task uploading, what we have done in this year, you can go through this, look at this paper. Okay. Okay. So finally, for the conclusions, there are many applications like autonomous driving, and so basically current autonomous driving is basically based on the behavior of a single vehicle. But in future, we have to make the driving more efficient in terms of long-term efficiency. Right? For example, not only avoiding accidents, we have to do the very efficient long-term driving. So that in that case, we have to do some collaborations between vehicles, not only single vehicle, single vehicle behavior. Right? We have to do some collaborative behaviors. Right? That's the basic, that's a very important future work, I think. So challenges, of course, the spatial temporal many challenges, and the technology would be like, of course, we have centralized control that is very efficient, but if the central server wants to control too many agents, that would have a problem of scalability. So we also have to consider decentralized. So decentralized and the centralized control, combining these two would be the one important issue. And also edge computing to reduce the delay, and also like kind of artificial intelligence technologies to improve the intelligence of an agent. So future research direction, just in my opinion, I would say like flexibility and the intelligence would be very important. Collaborative intelligence, collaboration between agents would be important. And of course, for the communication side, cross-layer design. And also we have to consider some kind of real scenarios because all the problems come from real world scenarios, right? So also computing, caching, and the communication would be, jointly considered in our system design. Okay, I think the time is so. Thanks a lot. Any questions? Yeah.
Thank you very much, Professor Wu, for the valuable presentation. And with this, I'm gonna ask Dr. Hisham and Dr. Muta if they have any comments or questions, and then start taking questions from everybody. Can you hear us, Dr. Muta?
Okay. Hello, I am Hisham al-Badawi. Konnichiwa, everyone, Minazam. Yes. I am glad to be here with you, Dr. Solomon Joe, for your nice presentation and a very informative presentation. We would like to start the questions. Please, the audience, if you need to ask Professor Solomon Joe, please raise your hand and we can start now. Professor Osamu Moda.
Can I ask?
Genki desu ka? Okay. Genki desu.
Thank you very much for very interesting talk. So you presented many techniques for vehicular networks. So let me ask you a fundamental point. So the performance presented result seems fine, but the performance of the vehicular these techniques may depend on the type of network, such as sparsity of the network and the vehicle speed or something like that. So if possible, could you explain some more point? The proposed technique is still effective in such a various type of network, or presented technique can be combined with to sort of the more flexibly combine something like that.
Thanks. Very good point. Actually, yes. Today I only mentioned about the the problem for the high density. Of course, for the sparse density, so there would be some kind of problems. And of course, for the sparse density, would be the problem would be different. And of course, like for the sparse density would be like how to utilize some kind of. So this is for the high density. So for the sparse density would be some kind. We cannot make a network based on the decentralized communication. So we have to use cellular communication. In that case, for the considering the burden of the cellular network, that would be okay. But sometimes if you want to use the decentralized communication, there would be another topic called delay tolerant networks. I didn't mention that here, but that would be also very interesting topic in terms of like disaster scenarios. For example, especially in Japan, we have some kind of the problem with the base station. So in that case, we can use the vehicle-to-vehicle communications and the delay tolerant networking technologies to deliver some information. That's kind of Of course, I agree with you. Like different scenarios requires different kind of solutions, and the common thing would be like we have to make a very flexible design. We have to make a protocol like that even works in sparse and also works in a high density scenario. That's very important. Yeah.
Okay. Thank you very much. Thank you.
Thanks.
Thank you, Thank you, Professor Solomon Joe. Next, please. Okay.
I think we have a question here.
Okay.
There is a question in the chat.
Question from Dr. Hana Shakir. Please, it's in the question and the answer subsection. It is talk about the speed of which data needs to be analyzed is an important issue, especially when transmitting images or videos. Could you please highlight the most recent techniques based on AI to face this challenge? Meanwhile, maintaining high image quality at the receiver. Please answer this question, please, Professor Solomon.
Yeah. This is also a very important topic. basically the data should be, yes, you are right, because data should be analyzed in a very real time. Sometimes for image processing, technologies should be incorporated to solve this kind of problem. So the basic AI approach is like based on the camera data or maybe LiDAR data. LiDAR means like we recently we have, you know, point cloud data, right? You use that data to do some autonomous driving. Currently there are some kind of approach would be like you know, for the real world side, for the autonomous driving, the one important issue here is like trustworthy learning, machine learning. That would be a very important issue I've been discussing in this kind of autonomous area, the autonomous driving area. And another one is just I mentioned before, federated learning would be, I think, would be a very hot topic in the future for the Internet of Vehicles, because what we have to, you know, we have to take care is the user privacy. So we have to take care of the user privacy, and then we also want to utilize the big data. In this case, we have to do some kind of distributed learning. That is the one of the very important hot topic in this kind of IOV applications, also in the AI area. Distributed learning, that would be answer, I think, because the question would be like AI technologies, right? So the current very hot topic would be distributed learning. Federated learning is one of them. There are many kind of distributed learning, because even for the federated learning, the every agent can choose different kind of, you know, model. For example, for this federated learning system, the model would be like a deep Q learning. For another federated learning system, the model would be deep networks, deep neural networks. That's totally different. One is only a deep neural network, the other one is deep Q learning. So the many combination for this kind of real system. Okay.
Okay, thank you. The next question, please. Okay, Dr. Solomon, may I ask you one question if you mind? Practically speaking, in the field of mobile communications, and this will be some sort of mobile IoT sensor networks based on fuzzy logic detection and route estimation algorithm, as I can expect from your presented slides. I have some comments, and please identify them. And slides looks like 23, 25, and so the expected KPIs, yes, 23. Next slide, please. Okay. Yes, it is seen that I think so the delay not in seconds, okay? And also the performance seems to be independent on the number of CPR flows.
Okay.
Especially you are talking about some sort of concatenating or collation or cluster formation based on fuzzy logic formation, as you said in slide 11 and 18, based on backbone algorithm in order to concatenate all traffic into one pipe to be looks like B, as you illustrate in figure 18, slide 18, the previous one, please. Previously, if I'm sure, yes, this one, 16, I'm sorry. As you illustrate here, the slide said that we will concatenate the different source into backbones cascaded to each other. And so the traffic will be some sort of congestion here. And how could you avoid this? Because if you avoid this, you will have some sort of buffering. And so the number of customers, as the number of customers will increase, the delay will expand. On the other hand, in your slide 23, you said that the delay is almost constant, independent of the number of flows. Please explain it to me, because I need to know this modeling, especially if you use some sort of queuing model or something, okay?
Yeah, that's a very good question. So first, let me first explain why this the right-hand side one is better. For example, you mentioned about the buffer delay or something like that. But if all the data can be sent on time, there will be no such long delay. For example, the main problem here is like if we use the many nodes to transmit, then there will be a problem for the contention. So for example, there is the collision happens, the backup time will be doubled, right? So in that case, that means very inefficient contention. So by reducing the number of senders, then we will get much better contention efficiency. That will result in very short delay. Yeah. For example, let's say S1 to Sn is directing this to the same B1, but this is okay because all the B1 can send very, B1 data can be sent to B2 with a very high speed. In contrast, for the left-hand side, like F11 is sending to F12, but the data rate is very slow. Because lower, right? So that's because the contention. Because much larger contention delay. That's one thing. So that's why our approach is better. Then for the result, you can say that in here, just if we further increase the number of traffic flows, of course, our approach will also increase. Of course, this like we just want to show that 10 up to 10 we can get 30. This is little increase. There is a very little increase in delay, of course, but as compared to the conventional one, that is really negligible. Very small. It's increasing. It's increasing, but it's very small because the contention efficiency due to the contention efficiency is very good here.
Yes, you said this in your slide 25. You said that the MAC 25. No, the next one. Yes. You said that the number of collide MAC frames will almost be the same.
Oh, yeah, here. Be the same because, yes. Why almost the same? Because the transmitter is very small. Number of transmitter, number of sender is very small.
Let's see. But the problem here is in this point, in the collection at B1 and distribution at BM, you have to make some sort of a scheduler, and the input scheduler or output schedule, where you have to pay some sort of delay.
Yeah, here, yes. BM
yes, you suffer from delay here and here, but in between, no delay. Or maybe neglect, yes.
I apologize, but I might have to interrupt because we are running out of the schedule here. Professor Hisham and Professor Wu, if you don't mind, maybe Wu would respond back to your concerns through email or some other sort. And we're really delighted today to have Professor Wu and Professor Hisham and Muda as the chairs.
Thank you.
Looking forward to see you in different events. And thank you very much.
Thank you. Thank you very much. See you soon. Okay, thank you. Bye-bye. Bye.
Thanks.
Okay, we are going to the next session. I leave the floor to Professor Mustafa Sulaiman from EJUST to present the chairs and the speaker.
Assalamu alaikum. Good afternoon, everyone. Good afternoon, everyone. This workshop was titled Next Generation Wireless Networks in Smart Cities. The chairs of this workshop is Professor Hussein Muftah, University of Ottawa, and Professor Masoud Al-Ghunaimi, Alexandria University, and myself, Mustafa Sulaiman, EJUST. The invited speaker is Professor Ahmed Khattab from Cairo University. He will talk about precision, agriculture, and Internet of Things field for smart farming. Okay. So Professor Muftah will introduce Professor Khattab.
Good afternoon, everyone. Professor Ahmed Khattab is an associate professor in the Electronics and Electrical Communication Engineering Department at Cairo University. He is also an adjunct associate professor in the American University in Cairo. He received his PhD in computer engineering from the Center of Advanced Computer Studies at the University of Louisiana at Lafayette, USA, in 2011. He received a Master of Electrical Engineering from Rice University in 2009. He also received his another MSc and his bachelor degrees from Electrical Engineering of Cairo University in 2004 and 2002, respectively. Dr. Khattab is the recipient of the Egypt State First Class Medallion of Excellence in 2020 and the Egypt State Encouragement Award of Engineering Science in 2017. He is IEEE senior member. He has a number of credits. If I go over them, they are really significant. His time will be quite thin at the end to present his presentation. However, I should say that Dr. Khattab has authored or co-authored 3 books, 3 book chapters, and 90 journal and conference publications, and a US patent. Before I do, and also he received several best paper and best thesis and best project awards from IEEE conferences. Dr. Ahmed Khattab, please, the floor is yours.
Okay. Thank you very much, Dr. Muftah, for this nice introduction, and it's my pleasure to meet you again. And thank you. I would like to thank the JAC-ECC team for having me over. And today I will be speaking about my experience in how the IoT can significantly change different fields of smart cities, such as smart farming and precision agriculture. So first, I will briefly introduce the concept and precision agriculture and how the Internet of Things technology can help advance such an important field. Then I would like to share with you 2 of my recent experiences with the use of IoT technology in the precision agriculture. More specifically, I will first talk about the project in which we developed an integrated monitoring system for forecasting the plant diseases for potato and tomato crops. Then I will talk about a recent collaboration with Spanish companies and Egyptian companies to develop a cloud-based integrated platform for monitoring best salinity and efficient irrigation in olive precision farming. Then I'll conclude my talk. So agriculture is one of the most ancient professions that man has ever worked. And up till now, agriculture plays a very important role in the economy of many countries worldwide, as you can see in this map, especially those developing countries in Africa, South Asia, and South America. Indeed, agriculture provides the main source of food, income, and employment to many people worldwide. For example, if we take Egypt as an example, and Egypt, as you know, is one of the main Middle Eastern and North African countries, the agriculture presents about 14 to 11% of the Egyptian GDP since 2009 till 2019. And according to FAO statistics, agriculture contributes to 20% of the Egyptian exports and up to 30% of the labor forces in Egypt, which means that about 1/3 of the Egyptian population work in agriculture-related businesses. Furthermore, if we take a look at the Middle East and North Africa in general, FAO statistics say that 50% of the food in this area is imported. Given the fact that the food prices is always increasing and the international market prices are going up and down depending on the situation, as we are seeing now in the COVID-19 crisis, the strategic importance of domestic agriculture becomes more clear and evident for the independence and the well-being of the citizens of different countries, especially in the third world countries. However, as we all know, agriculture faces several problems that can vary from the diseases and pests that affect the crops to the problems faced in the irrigation and the application of fertilizers. For instance, if we want to talk about the diseases and pests that affect the crops, they can result in a dramatic decrease in the productivity and the quality of the crops. For instance, in 2001, some of the potato diseases caused 60% of the crop to be lost. Likewise, an important pest that affect the olive plantation is the olive fruit fly, which can cause damage to up to 100% of the harvested fruit and up to 80% quality reduction in the table olive oil value. The old or the traditional practice in combating the disease and pests is to apply excessive fungicides and pesticides to counter these diseases and pests. However, such excessive application of fungicides and pests will definitely degrade the quality and the quantity of the crops. Furthermore, it will make the crops poisonous and not appropriate for human use or for exportation, which will have significant degradation of the agricultural process. Furthermore, the use of chemicals in the disease and pest control mechanisms will cause harm to the environment and will cause pollution to the environment, which is a huge risk or a huge downside that we want to avoid. So there is a need to be very careful in applying the pesticides and fungicides to combat the diseases and pests encountered in the agriculture fields. Likewise, another challenge is the irrigation and fertilization application. This is of very particular importance because of the need of the plant to do the different phases of growth varies according to different places, to different weather conditions, to different land types. So we need to be very careful in applying the water and the fertilizers. However, the traditional way also was to use massive or to flood the entire field with water, as the case here in Egypt, which is totally non-appropriate. And there are many other factors that affect the application of irrigation and fertilization, specific to certain places, such as Egypt, which has 25% of its agricultural land is reclaimed desert plots, which lacks nutrition, it lacks the availability of water sources. The soil in the Sahara Desert plots lack nutrition at all and results in very low yields. Furthermore, the building of the dam in Ethiopia might result in water shortage in Egypt. Indeed, according to FAO, Egypt is estimated to be among the top 35% water deficient countries in the world. So again, we need to be very careful in the use of water and fertilization in order to combat all these negative sides in the irrigation and fertilization application, as well as the case in the disease handling. The solution to all these problems is the term precision agriculture. Precision agriculture refers to a mechanism in which the right set of inputs, for example, water, fertilizer, fungicides, are applied at the right time and place whenever needed by the plant, which considers the microclimate conditions to control the application of such resources. Indeed, the US formally recognized the precision agriculture as the main type of agriculture in 1997 by the US Congress, and since then, precision agriculture has been adopted in many countries worldwide because of the many advantages it brings to the table. For instance, it increases the crop quality and quantity, because here we are applying or we are treating each plant individually and applying the right set of resources whenever needed. No excessive water, no excessive fertilizers. So it economizes the needed resources. Furthermore, it provides a better estimate of the real crop needs and accordingly adapt to the needs of the plant. And it provides the farmer with better prediction of the crop yield and allows the farmer to set up a detailed history of a given field practices and the crop output in order to help him plan and time manage and decide what to be done for the next cycles of agriculture. More importantly, it protects the environment because of it doesn't allow the excessive use of chemicals that cause pollution to the environment. However, precision agriculture faces different challenges, such as the need for maintaining the system sustainability given the harsh condition or the variable condition in the field in which the precision agriculture system operates. Also, there is a need to achieve automated and accurate yet low-cost measurements of the required parameters of the environment without any human intervention in order to achieve accurate sampling of the data. Collecting these measurements and processing them should be done in a timely manner in order to take the most appropriate actions in the appropriate time. Furthermore, doing all this should be done at very low maintenance requirements and very low cost. And in countries like the developing countries, there's a need to secure and guarantee theft-proof environment for placing the equipment used for precision agriculture. And here comes the importance of the IoT and how to make the precision agriculture IoT-fied in order to address all these challenges of providing automated yet accurate and advanced processing of the information to be collected. In the next few slides, I will briefly introduce the Internet of Things technology and how it provides an excellent solution for smart precision agriculture. The Internet of Things paradigm refers to a network in which physical objects, which can be anything, it can be our cars, our appliances, any devices or any building that can be uniquely identified with a virtual representation in an internet-like structure such that it can be connected to the network. And these devices are embedded with electronic hardware and software and sensors with network connectivity in order to communicate with each other and communicate with the internet. The term Internet of Things was first proposed by Kevin Ashton in 1999. Typically, IoT systems consider the shown layered architecture, which is composed of 4 layers. The lowermost layer is the sense and identification layer, which corresponds to the physical layer, which is responsible for gathering the information from the environment or doing some action to the environment. And this layer is basically the physical layer, which has the sensors. And now we have thousands or millions of sensors that can sense practically anything, and actuators that takes action in the environment. The second layer is the network construction layer, which is responsible for transmitting the collected information through any wired or wireless communication technology. The collected information is transformed to the third layer, which is the management layer, which is responsible for processing the gathered information and storing them in data centers and applying smart decision, artificial intelligence, and securing the data or do any information processing techniques needed over the collected data. And finally, the last layer is the application layer, which provides an interface to the humans through any API or any data visualization technique. And you can see that the 3 main enablers of the IoT technology is the device miniaturization. And as you can see, the size of the computing devices went down from the size of the mainframe in the 70s or 60s. And now we have microprocessors that can be as small as they can fit inside a medication bill or so. Another key enabler is the cloud computing and the advances it's witnessing right now, and how we can now store data, process data, and have different applications that connect to this cloud. And furthermore, the artificial intelligence and machine learning and other analytical approach that helps us to analyze the collected data and really find trends and make them useful. Because it's very important to really make use of the collected data, not just collect pure data. Consequently, the IoT technology has found its way to almost every aspect of our modern life in smart cities, in buildings, in streets, in factories, in the sea, underground, and in smart farms, as we are discussing in this talk. So basically, sensors are everywhere now. And this can be further demonstrated by the shown figure, which shows in the blue line, the population of humans have increased from 6.3 to 7.8 billion human beings from 2003 to 2020, which is about 1 billion human increase. On the other hand, the number of devices that are connected to the internet has increased from almost 1 billion to 50 billion smart objects connected to the internet. And the communication or the wireless technology have totally changed from just having each person have just one mobile phone that connects him to the network to communicate with other humans, to now we have almost 6.9 devices per person to allow him to interact with the environment. We have smart doors, smart cars, smart shoes, smart watches, smart Google smart glasses, and so on and so forth. There are many other numbers that give the change in the wireless technology. For example, Huawei forecasts that the number of connected devices by 2025 will be 100 billion IoT devices. McKinsey Global Institute suggests that the financial impact of the IoT on the global economy might reach 11.1 trillion by 2025. There are many other different numbers that shows the importance and the significance, growth, and influence of the IoT. I cannot say that there is one that is very accurate, but they can give us a big picture of the importance of the IoT in our lives. That said, now we are ready to hear about our experiences with IoT in precision agriculture and smart farming. The first project I would like to talk about is the integrated monitoring system for plant disease forecast, which we have developed for forecasting the diseases facing potato and tomato crops. This project was done in collaboration with the Agricultural Research Center in Egypt and was funded by the Science and Technology Development Fund, STDF, here in Egypt. The main goal of this project was to develop a system, the hardware and the software, which predicts the outbreak of, or the condition that will lead to the outbreak of the diseases, and accordingly advise the farmer with the best action to be taken in order to combat such diseases. And this is the system function overview, which is composed of three main parts. The first part is the hardware, which is composed of the sensors, both underground and above ground, which collects all the attributes that were recommended by our agriculture experts. On the other hand, the agriculture experts did a lot of in-field and lab experiments in order to develop the mathematical models that predicts the outbreak of the different diseases that we considered in our research. The sensors collect the data and wirelessly communicate them to our research center in order to process them and take the decision. And in order to do so, we have implemented what is known as an expert system. An expert system makes the control and corrective actions, initiate the early warnings, and produce maps and visualize the events in order for the farmer to be able to monitor what's going and help intervene if needed. Furthermore, the collected data was evaluated based on the initial models developed by our agriculture experts. However, we were using AI and machine learning techniques in order to further improve the models of the diseases. For the first part, in which we were aiming at implementing or developing an agriculture weather station, which collect the required information, such as the wind speed and direction, air temperature and humidity, solar radiation, leaf wetness, rain meter, and the soil water content or the temperature, which were buried underneath the ground. We have specified the needed sensor with the required accuracy and resolution recommended by the agriculture experts. And we have built our agro-weather station based on an Arduino Mega, which was powered using a solar panel and rechargeable battery as shown in this schematic. The station collects the data and sent an SMS message to the remote center, which contains the information as shown is in this slide. The expert system software design is composed of three main modules. The first module was responsible for logging the collected data that was sent by the SMS messages. The other part is the AI module, which is based on the ground layered architecture for integrated reasoning, the GLAIR platform, which learns the trends in the data and come up with decision what to be done and when this action to be done, which is a reasoning platform. Finally, we developed an application interface that allow the end user to see the statistics of the collected data and the trends and have histograms of the information. And this is an example of a disease model, which is a set of conditions upon which a decision whether or not to apply a specific treatment or not. This is just a simple model just for illustration. And here is some snapshots of the application interface that we have developed, which allows the farmer to define new weather stations and define the number of events and which events, and define the different ranges for the different events and when they are considered to be harmful or not. And this is example of the reported data. And as we have 6 of these agro-weather stations deployed in different governorate around Egypt. Actually, we have in 6 governorate. And these are real measurements by our base station. And the outcome of this research has been published in Computers and Electronics in Agriculture journal. The next project that I would like to talk about is a collaboration with the Spanish government in the Egyptian-Spanish IT Innovation Program, ECTIP, which was funded here in Egypt by the IT Industry Development Agency, or ETIDA, and in Spain, it was funded by the CDTI, which is equivalent to ETIDA in Egypt. And the collaboration or the team was composed of Cairo University, Smartec, which is a leading IoT company here in Egypt, and Ceresco, which is a multinational company that is based in Spain, which is called Ceresco. So the goal of this project was to develop a cloud-based integrated platform for monitoring pests, salinity, and efficient irrigation for olive precision farming. The motivation of this project was the fact that Egypt and Spain are 2 of the world's leading table olive producers, with Egypt producing 18% of the world production. On the other hand, Spain is the largest olive oil producer in the world, with more than 45% of the total world production. Spain is the first country in the planted area. Spain had in 2017 2.6 million hectares devoted for the cultivation of olives. Therefore, exploiting the ICT technology in such a growing sector represents an excellent opportunity to boost agriculture productivity in both countries. However, the olive farming faces many challenges. We identified the most important or the most severe problems that face the olive farming, which can be summarized in the next few slides. The first and the most important disease that affects the olive trees is called the verticillium wilt. Verticillium wilt is a soil-borne fungi which invades the root system of the olive trees when the temperature is cool. So it starts in winter and ends in spring. It suffocates the trees, as shown in this figure, by preventing the water from reaching the xylem, which causes the tree to suffocate. So again, the progressive invasion usually occurs in the late winter through spring, and when the temperature increases again above 30 degrees, the fungus is inactivated. However, it becomes active again when the weather cools down. However, there is no cure whatsoever for the verticillium infected trees, even though some people try to prune the affected branches. However, verticillium wilt is a root-related fungus, which cannot be treated by just pruning some of the branches. So this is one of the goals of the project, is to early predict the occurrence or the condition that will lead to the outbreak of the verticillium wilt disease. Another important problem that we are targeting in this project is the fact that the accumulation of the salt in the water used for irrigation, especially in countries like Egypt, as we use saline water for irrigating the olive trees in the Sahara area and in Sinai and in Matruh. So the accumulation of the salt will cause some surface that is impermeable, and the roots again suffocate and stop exploring the soil for nutrition, and hence the trees will die. The accumulation of salts is affected by many factors as shown in this figure. More specifically, the climate conditions, the soil type, the irrigation water quality, especially when saline water is used, and also the type of the tree, because there are different types of olive trees worldwide that act differently with to the irrigation water. So we want to develop some recommendations on how to use saline water for irrigating the olive trees based on the census information. The third and the last problem that we are tackling is the olive fruit fly, which is an ancient pest that have been identified in the Mediterranean region since the 3rd century BC, as was written in the Greek Roman writings. The olive fruit fly presents a major threat on the olive plantation, and it may cause up to 100% of the harvested fruit to be damaged, and it can cause losses to up to 80% of the olive value because of it lowering the quantity and the quality of the olive oil. The population of the olive fruit fly depends on several climatic conditions, such as the humidity. It flourishes in humid environments, and also when the temperature goes between 20 degrees Celsius and 30 degrees Celsius, it presents an ideal environment for the olive fruit fly to flourish. So now we can state our objectives is to set a step forward in the Egyptian and Spanish strategy of using technology to improve the agricultural practices by monitoring the environment factors affecting the olive plantation, and detect and count the major pests such as the olive fruit fly, and monitor the irrigation water and soil salinity characteristics, and present a profile or advice recommendation on how to use saline water for irrigating different types of trees in different land, in different types of lands. In order to achieve these objectives, we are planning to have, or are working on having, a hardware platform that is composed of the monitoring station, such as the one developed in the first project, as well as having a pheromone trap that attracts the olive fruit fly in order to count them and apply the appropriate countermeasure accordingly. Associated with this hardware, we are working on developing a decision support system, or a DSS, that serves as the single point of access to all the collected information, as well as a platform for implementing our decision-making processes and machine learning and artificial intelligence decision-making processes. Before we implement the hardware, we planned the network architecture as shown in this slide. We are having some remote sensor nodes to be deployed near to each tree that we are monitoring closely, in order, for example, to assess the irrigation water effect on the plantation. We are also having the pheromone traps that attracts and counts the olive fruit fly. These remote sensor nodes and pheromone traps will collect the needed information and relay them to the main node, which is acting as a gateway that connects the system to the network server, which in turn connect and relay the information to the cloud platform, where the AI and machine learning and other APIs exist. Hence, the users can connect to any internet-enabled device to this cloud platform in order to access the data or issue any commands. For communication between the remote sensor nodes, pheromone traps, and the main gateway, we chose the LoRa communication paradigm. The LoRa communication or the LoRa WAN features are very attractive because using a single gateway or just one base station can cover entire cities or hundreds of square kilometers. Indeed, the coverage range of the LoRa is 9 miles or 15 kilometers approximately. It provides appropriate data rate of 50 kilobits per second, but most importantly, the lifetime of the LoRa technology is about 10 years. Hence, it alleviates the need for harvesting the energy frequently. Consulting with our agriculture expert, we have identified the needed weather attributes that need to be measured by our weather station and the ranges and accuracies needed for them. And similarly for the soil sensors, and as you see, we are deploying sensors underneath the ground at different levels in order to have a complete picture of the salt accumulation underneath the ground. Likewise, we identified the LoRa technology transceivers and the camera board that are needed for best performance of our system. And accordingly, we have implemented the different nodes and the gateways as shown in these few slides. And now we are done with this phase. And currently, we are deploying the nodes in several test beds, both in Egypt and in Spain. For instance, in Egypt, we have partnered with a groove near the Suez Canal, as shown in this figure. This groove has different types of soils, both deep sandy soil, sandy loam soil, and shallow clay soil. The irrigation there is done through a highly saline water. There are more than 14,000 trees of multiple olive varieties, both Egyptian olive, Spanish olive, Italian olive, with different trees, ages, and different characteristics. Likewise, our Spanish partners have identified several farms according to the fact that they have new plantations, and these plantations have signs of verticillium wilt that we are targeting to predict. For the best monitoring, for the olive fruit fly monitoring, 3 different farms have been identified in Sevilla, Cordoba, and Jaén. Also, we have identified a farm in Valencia for managing and monitoring the irrigation water salinity. In total, the Spanish test bed is composed of 5,678 hectares. On the software side of the platform, we have developed a cloud-based platform, which is responsible for recording the acquired data by the soil sensors, the environmental sensors, as well as the pheromone traps. The platform processes this collected information using artificial intelligence techniques in a predictive model of pests, diseases, and irrigation optimization. And I will briefly talk about one of these models for pest detection and counting. And finally, the platform provides a very professional application layer web interface in order to allow the users to access the information. What we have done in order to count the olive fruit fly is what is known as integrated pest management system, which is an efficient way to reduce the population of the harmful pests. Basically, as shown in this figure, traps are deployed across the field, and these traps are filled with some substance which are called the pheromone, which attracts some species of flies. And here we are using olive fruit fly attractive pheromone trap, and they will just attract the flies, and once they get in, they are stuck. So we take pictures and develop a decision support system that counts the number of captured pests and accordingly advise the appropriate action to be taken. And actually here we are partnering with a company that does biological countermeasures, not just using pesticides as the traditional way. So the traditional way for olive fruit fly counting was manual, in which the farmers go to each one of these traps and manually count the number of pests, and accordingly they decide what to be done. However, such a manual counting technique is labor intensive and error prone because it's dependent on the human in the loop, expensive, and very, very slow. Later on, there was a semi-automatic approach in which digital images of the stick sheets can be captured and analyzed by the human experts in order to recognize and count the pests, which is definitely better than the manual counting. However, it still has man in the loop, and therefore it will suffer from the same problem suffered by the manual counting. Our approach, on the other hand, is totally automatic. We will add cameras that capture the trap photo and send it wirelessly to the cloud platform. And we are using state-of-the-art machine and deep learning techniques in order to detect and count the number of pests. And this is totally remove the human from the loop in order to achieve a completely automated real-time pest monitoring system. And actually, we did a detailed survey of the different olive fruit fly counting, and we have a book chapter that was recently accepted for publication in the Deep Learning for Sustainable Agriculture by Elsevier. Accordingly, we have designed a new approach which detects and counts the olive fruit flies from the captured images with high accuracy and our goal is to have its size as small as possible in order to fit in the embedded system, not only in the cloud. And also we want, or we have trained our system using the DIRT data set available for all the float flight. And this is an overview of the developed framework, which has three main components: image preprocessing, data augmentation, and then the you only look once, or the YOLO platform for counting and detecting the occurrence of the oil float flight. Briefly, the yellow mean color normalization step is to normalize the intensity or the light intensity inside the trap, as is shown in these pictures. Then we increase the size of the training data by different augmentation techniques. And then we have modified the YOLO platform in order to achieve the highest possible accuracy. And our initial results have shown that our framework significantly improved the precision, the recall, the map, the F1 score compared to the original YOLO platform. So to conclude my talk, the use of IoT in smart farming and precision agriculture is a step forward in the strategy of using the ICT technology to improve the agricultural practices. It increases the farming production quality and quantity and reduces the environmental pollution. It improves the competitiveness of the farmers and facilitates the adoption of technology and technological innovations. Furthermore, it contributes to achieve sustainable agricultural development, which definitely will help different countries worldwide. Thank you, and I will be glad to hear any questions.
Thank you. I have here a question from Hani Ragai, saying a few days ago when we heard about farmers' capability to use their mobiles for PA. How credible is this?
Professor Muftah, can I ask a question at the end? I am Amin Shukri from eJust.
Okay, thank you.
Thank you.
Okay. Yeah. Actually, we had really a big problem in applying our concepts when we were working on the potato and tomato. Indeed, we need to have some incentive for the farmer to adopt this technology. For instance, we were sending them text messages: if you apply this fungicide or if you do this action, you will receive 50 Egyptian pounds or so. So there definitely we need to have some incentives in order to make the simple farmers adopt such technologies. But once they appreciate and they understand the gains that we receive, they will automatically go for this option, and they will forget about the traditional ways of farming.
Yeah, thank you very much. Dr. Amin Shukri, please go ahead with your question.
Yes, thank you, Professor Muftah. I am pleased to see you with us today and hope to see you at eJust premises in a very near future. Also, I thank Professor Khattab for this nice presentation. My question is about what, intelligent reasoning system he has used, because in his presentation, of course, he talked about several models, but sometimes he talked about an expert system, about an intelligent agent, machine learning, deep learning. So my question, if he can give us more precisions about what reasoning mechanism he is using, or a hybrid of several things. I hope that he understands my question.
Sure, definitely. Actually, it's application dependent. For instance, in order to forecast the evolution of weather, in order to predict the weather condition that would affect something like the growth or the development cycle of the olive fruit fly, we are using time series analysis, using long short-term memory, and you're using other techniques that predicts the time series of the growth or the evolution of the temperature. On the other hand, we are using deep learning technique, which is called YOLO, you only look once, which is like deep learning. It's a convolutional neural network which predicts or it divides, as shown here in this picture. It divides the picture and take decisions and do some classification in order to identify the best. On the other hand, on the first platform, one of our collaborators has developed something that is called the GLAIR, the grounded layered architecture with integrated reasoning, which was used to refine the models that were initially developed by the agriculture team.
Okay.
So again, it's application dependent. There is no one answer. There is no hybrid. Again, depending on the application, we can have a specific technique to address or to identify the needed data, or to analyze the available data.
Thank you very much, Professor Khattab. Thank you.
You're welcome. You're welcome.
Thank you very much. A final question from Dr. Hana Shaker. What are the most common types of attacks in this area of research, and what are the most common anti-spoofing methods to mitigate these attacks?
This is a very good question. And actually, we have not considered this dimension yet. We have more fears of people stealing the actual hardware. So we are just building fences around the sensors in order for them to not be stolen. We haven't considered this very important research, of course, securing the data, but I don't have an answer for this question. We haven't considered it yet.
Okay.
We have some security features for the cloud system in order to prevent our platform, but these are built in the used cloud system. So, but research-wise, we have not developed anything yet.
Okay. Thank you. I have also here, I would like to ask Dr. Abu Zahad to ask a question, please. Go ahead.
Okay, thank you very much, Professor Muftah, for helping JAC-ECC in sharing the session. Thank you, Professor Masoud, and I am glad to see Dr. Ahmed Khattab.
My pleasure, Dr. Muhammad, to see you, and thank you for the invitation.
In fact, I am not following the lecture from the beginning, but I have a little question about early detection of pests. The system can detect early problems in agriculture farms.
Yes, yes. I didn't elaborate more, but I will tell you exactly what happens. We have developed predictive models that predict the evolution of the temperature, for example, for the next year. And accordingly, there's something that's called the day degree, which computes the temperature units that affect the growth of the disease. And accordingly, we can forecast or foresee when the disease or the pest will have an outbreak, or it will develop, or the larva or the egg of the fly will hatch. And accordingly, we can take the appropriate action. For example, we can advise some people to shake the trees to make the eggs go under the ground, and so on and so forth. So this is how we are tackling the forecasting problem.
Okay. Is there a reason to adopt your system in Spanish farms, not in Egyptian farms?
They are facing different, during the negotiation phase, they were facing a lot of problem with the verticillium cell. The verticillium wilt, it's not severe in Egypt, but they are suffering from it a lot. However, they are not using saline water, they are using normal water. So they don't have the salinity problem. But here in Egypt, we have the salinity problem. So in the negotiation phase, we reached like a middle ground or a common ground in which we address both the Egyptian and the Spanish problems encountered in the olive plantation.
Okay, thank you very much. Thank you, Professor.
Thank you, Dr. Muhammad, and thank you very much for having me over.
Thank you very much. And I would like to end the session at this moment. And I would like to thank very much Dr. Ahmed Khattab. And it's a pleasure indeed to meet you again.
It's always my pleasure, Dr. Hassim. It's always my pleasure. Thank you very much.
So if Professor Masoud has a question.
Thank you very much.
Yes. Yes, Dr. Masoud, please go ahead.
I just have one question regarding the sensors that you presented you put in the ground to make the detection. Are these ready-made sensors, or you developed it?
No. Actually, we thought to develop them because they are measuring the conductivity of the water. We thought we are having Dr. Sarak Habib, Professor Sarak Habib, which is very well known, and we thought to develop them locally. But at the end, we decided to import them. But yes, you are right. They can be easily manufactured locally.
Okay. Thank you very much. Thank you for the great talk. Thank you.
You are welcome. Thank you very much.
Thank you, Dr. Masoud. Is there any first question at the end? Anyone would like to ask questions? All right.
Thank you so much, Professor.
Okay.
Thank you so much, Professor Ahmed Khattab, for your interesting talk. And also thank you, Professor Muftah, for chairing the session, and Professor Masoud Al-Ghunaimi. Thank you so much.
Thank you.
Thank you.
Okay, thank you all for this is the end of our session. I would like again to thank our chair and our speaker. We are going to move to the next speaker, Professor Ahmed Al-Wakil. And our share session will be Professor Muhammad Sharaf Said. Professor Wakil. Okay. كان في دكتور صراحة بايع المفروض هيخش هيجون مش هيبقى موجود ولا لا هتشير دلوقتي بقى
Okay, good afternoon, everyone. It's my pleasure to introduce Dr. Ahmed Al-Wakil to give a presentation about supercapacitors. Please allow me to give a brief overview and short bio about Dr. Ahmed. Dr. Ahmed, he got his bachelor and master degree in electronics and communication from Cairo University, and the PhD degree from the Department of Electrical and Electronic Engineering, National University of Ireland, University College Dublin. After that, he joined the Department of Electrical and Computer Engineering, Sharjah University at United Arab Emirates. He's now a full professor. Dr. Ahmed actually is very active in the research field. He is a visiting professor to University of Calgary, Queen's University, Ohio State University. He has more than 300 publications and 2 US patents, and authored 2 books. He is a member in several committees for prestigious conferences, and of course a reviewer for famous transactions and conferences. So Dr. Ahmed, you have the floor. You have about 30 minutes for your talk, and then we'll open the floor for questions.
Thank you very much, Dr. Muhammad. I just want to make sure that the screen is clear, the presentation is seen on your side, and also my voice is clear. So if you can confirm that, I can proceed, inshallah.
Yes, we can see your presentation.
Okay, thank you very much for inviting me to give this talk in the conference, and I hope that at the end of the talk, the message regarding supercapacitors and their importance will be clear to the audience. And also please feel free during the presentation to ask any question to make things more clear. So my topic today is about the supercapacitors and their performance modeling, and also their applications. So the outline of my presentation will start with motivation about supercapacitors and why they are important. The structure or the internal structure of supercapacitors, will try to run a little bit fast in this. And also we focus on the supercapacitor circuit models, and then how to calculate the effective capacitance, how to calculate energy and the power for these special types of capacitors, the different applications, and then we move to the future applications. Actually, this topic is really an interdisciplinary topic. It requires knowledge and background in electrochemistry, in mathematics, and particularly in something called fractional calculus, which is slightly different from the normal calculus that everyone is used to. It also requires knowledge in circuit theory, and it is, of course, applied in renewable energy. So it is a very interdisciplinary topic, and therefore you will see also from the example for the publications that have come out of working in this topic that we can publish in many different directions depending on how you look at this topic. So what is the motivation for using these supercapacitors? Basically, as you all know, there is a huge demand in the market for fast rechargeable energy storage devices. Now, everyone has a mobile phone, and you can actually see how long it takes to charge your mobile phone. So we need something that can be charged very fast. The problem is very clear also when we look at the market of hybrid cars and electrical vehicles. These cars or these vehicles rely on batteries until today. And of course, the major problem is the time required in order to recharge the battery so that this car can be working again after the battery has been depleted. So we actually need fast rechargeable energy storage devices, and this is one of the main driving forces for developing supercapacitors. Also, there is a need for higher efficiency. That means we need higher power and energy per unit weight. As you all know, the batteries, and particularly the large batteries that are used for electric vehicles, for example, these batteries are very bulky, very heavy also, and this affects the performance of these electric vehicles. So we are looking for something that is lighter in weight without losing the power and without losing the energy efficiency of these devices. There is also the environmental considerations, as we would like to extend the lifetime of the energy storage devices. Also, everyone knows that after a few years, for example, of using batteries, these batteries tend to lose their capability of storing energy, and therefore they have to be thrown away. When you throw away your battery, this is a very something very damaging to the environment because the materials are poisonous or they are very difficult to get rid of. So we need also to develop some energy storage materials that are more environmentally friendly, that would have a long lifetime, not 3 or 4 years, but more than that. And supercapacitors offer many of these requirements, as we will see throughout this presentation. The last point that motivates the working and the development of supercapacitors is the lower fabrication cost and also the lower maintenance costs. So all of these points are driving forces for producing and working in supercapacitors. Now, if we look at this power energy chart, this chart is quite important in showing us a comparison between the different types of energy storage devices. On the x-axis, we have the power density, and on the y-axis, we have the energy density. And there is a collection here of different types of energy storage devices. Now, if you look at fossil fuels, for example, all the oil-based, gasoline, diesel, and all these different fossil-based energy storage devices, you can see that they are on the top of the chart here in red. They have a very high energy content, and they have also moderate power density given their weight. So they are the best in terms of energy storage capability so far. However, if we look, for example, at lead acid batteries, you can see the lead acid batteries in purple color on the graph. These batteries have much lower energy density compared to fossil fuels, and they have moderate power density also given their weight. When we compare them, for example, to lithium-ion batteries, the yellow color here is for lithium-ion batteries. You can see that they are much better in terms of the power delivery, their power delivery capability when compared to lead acid batteries. However, they have also the same energy density capability. Now, supercapacitors that, as you can see here in the market box, the box that I marked in red here, supercapacitors are slightly better in different, not slightly, actually are much better in terms of power capability compared to batteries. However, they are still less in their energy capability when we compare them to batteries. So they are far better when you are looking for high power density, but they are still behind the batteries in terms of energy density, as you can see in this chart. Now, also on this chart, you will see there are diagonal lines, and these diagonal lines show you the time needed to recharge or to get out the energy from the energy storage devices. So at the top here, for example, you can see a diagonal line with 10 hours, 1 hour, 0.1 hour, and down to the approximately half a second or 0.36 of a second. And this is basically the time that is required to charge, for example, normal capacitors that we have or we are used to deal with in our labs. So as you can see, the supercapacitors are very good in terms of the time required to recharge. They can typically be recharged in fractions of a second up to a few seconds. For example, here 3.6 seconds is the typical time needed to charge a 1 farad capacitor. Now the charging time is much, much less when we compare it to batteries. And this is why the supercapacitors are gaining this huge interest because they can be charged very fast. They can have high power density, although they don't have the same energy density as batteries. Now, supercapacitors are already available in the market in many of the standard vehicles. As you can see here, this is one of the BMW X1 types. And on the chart of components in this model, this is a 2016 model, the first actually BMW model to have supercapacitor. Down here at the bottom, you can see the symbol for an ultra capacitor. And what is the function of this supercapacitor inside the vehicle? Basically, it can restart your engine in less than 400 milliseconds. So while you are standing still in a traffic light, for example, there is no need for the engine to keep working. We can switch off the engine, and later on, after a few milliseconds, the engine can restart in less than 400 milliseconds. And that is why these supercapacitors are being employed in new types of vehicles, such as this BMW, for example. Is my voice clear?
Yes, Doctor. Please
Dr.
continue.
Mohammed, my voice is still clear, no problem?
Yes, Dr. Ahmed, please continue.
Okay. So if we look at the structure of modern electric vehicles, as you can see here in this presentation, most of the new electric vehicles rely on batteries and supercapacitors together. So the current situation in the market is that you cannot get rid of the batteries until now, but you can also add extra power by using supercapacitors together with the battery in the same vehicle. So the situation is that the batteries actually are charging the supercapacitors, and the supercapacitors are delivering the power to the engine. So the engine doesn't take the power directly from the batteries, it takes it from the supercapacitors. And this is because in case you want to accelerate your car very fast, you want to move from, for example, steady state or no motion into very fast motion, you need a lot of power. The battery is not capable of delivering this power, and therefore you have to take this power from the supercapacitor, which is basically charged from the lithium-ion batteries that exist in these electric vehicles. However, as you may be aware, or some of you may be aware, the American company Tesla, which is the main manufacturer of electric vehicles in the world now, they are actually doing experiments on supercapacitor-only car. So this car, as you can see in the picture at the bottom, should be able to recharge or fully recharge in 4 minutes. This means that we don't need batteries in this case, or batteries will not be used in this type of car. It can recharge in less than 4 minutes, and it can start working or running on the road without any further delays due to the current situation of long charging time. Now, allow me to show you this video, which also shows how fast the acceptance of supercapacitors in the industry of electric vehicles is going on. So I'm going to switch or start this video, and I hope that you can see the development of new generations of buses, electric buses that are completely running on supercapacitors without any battery involved in this case. if you look at the video is clear, Dr. Muhammad, just to make sure that the audience are seeing the video clearly?
Yes, yes, it was clear.
So if you look at this new type of electric bus here at the back, you have the ultra capacitor or super capacitor modules that are supposed to be charged in order for this bus to go around the city without producing any pollution. As we go on through the video, you will see that this also requires new infrastructure that has to be developed throughout the city in order to charge these supercapacitors or ultra capacitors. Sometimes they are called ultra capacitors, some other times they are called supercapacitors. In order to recharge them very fast, we need to also develop the infrastructure in the cities, as you will see throughout the remaining part of this video. I will try to skip a little bit so that we don't waste our time, but this part here is very important. So this part here of the video is really important. You will see how the bus is being recharged in a few minutes, maybe less than 1 minute, and then it is off to go and continue its trip. So I will stop the video here to save the time of the presentation, but I just wanted to show that this technology is already being deployed in electric vehicles and particularly in intercity electric vehicles. And I think in the very near future, we will see these types of battery-less electric vehicles that depend completely on supercapacitors in the market. So now I want to present the idea behind supercapacitors and why they are different from normal capacitors, and just to explain from where or the huge or the large value of capacitance arrives. So everyone knows from the undergraduate information in physics and electrical engineering that basically the capacitance is a function of the cross-sectional area and the distance d separating two parallel plates. So this is basic physics. When we have two parallel plates and they are charged, there is a capacitance between these two plates, and this capacitance depends on the cross-sectional area and also the separation distance between these two plates. So how can we maximize capacitance? In order to maximize capacitance, according to this equation, there is only two options. Either we maximize the cross-sectional area, A, or we minimize the separation distance, D. So this is exactly what happens in supercapacitors. We achieve high values of capacitance by minimizing the separation distance D and also maximizing the cross-sectional area A, as you will see in a few seconds. So the double layer capacitance or electrostatic double layer capacitor basically relies on carbon materials and also relies on an electrolyte that is fitted between these carbon materials. With this type of structure, the separation distance between the charges on the electrode plates can go down to approximately 0.5 nanometers. So we have a separation distance between the plates where the charges accumulate in the nanometer level. This is why we are able to achieve extremely high capacitance values using these types of capacitors. So what happens in these supercapacitors is that we have an electrolyte or a liquid electrolyte, and we have two carbon electrodes on the left and on the right. When the charges, on the electrodes are accumulated, we have basically a very small capacitance, a very large capacitance on the left, and another very large capacitance on the right, and that is why they are called double layer capacitors. So supercapacitors also are known as double layer capacitors. And the separation distance D, as I said in the previous slide, is typically in a few nanometers or even less. And this means that we have a total or combined capacitance of these two double layers which is extremely large. So again, this is a more explanation of what happens when the capacitor is charged and when the capacitor is discharged. But in general, the main idea is that we have two capacitors at the electrolyte interface. So on the left-hand side and on the right-hand side, we have two small barriers, but they create huge values for the capacitance, and that is the reason for having such large values of capacitance. So in case of supercapacitors, what we actually are able to achieve is to reduce this separation distance down to the nanometer level, and at the same time, we increase the cross-sectional area extremely by using different types of new materials like activated carbon, which has a large surface area, and also it has a fractal porous structure. So basically, looking at this equation, we are now not limited by the ratio of the area to the cross-sectional distance, the cross-sectional area to the separating distance anymore. We can increase the value of the capacitance by using these new types of materials and this idea of the electrolyte electrode interface. So to look at the structure of a supercapacitor from the inside, this is a picture of the carbon pores or the carbon electrodes that are being used to fabricate these supercapacitors. As you can see, they have a lot of pores or fractal structure, and this basically is the reason for the large surface area. They are just like a sponge. Basically, the surface area from the inside and the outside is huge. And as we put these carbon materials inside the electrode, we actually create a distributed system, which is considered like an infinite RC network. So we have resistors and capacitors, infinitely inside this fractal structure between the electrode and the electrolyte. And this means basically that when we start looking at how to model supercapacitors, we can actually model these devices by a distributed infinite RC network. So from this slide onwards, we will start to move from the materials level to the circuit modeling level. How to model a supercapacitor and why is it different from the normal capacitors that we are used to before. So the reason why these capacitors or supercapacitors are different is that they are actually, from their internal structure, they are actually composed of a distributed infinite RC network. This means that we can look at them as a network of resistors and capacitors like the one you see here on the screen, but this network is infinite. That means it is in all three dimensions, and we don't know exactly how many sections we have. It is a huge amount of sections. Usually there is also, in the model of a supercapacitor, we also include a very small inductance to model the connections of the electrodes. And also there is a leakage resistance, which is usually quite large. Sometimes we consider it just to be open circuit. So in terms of admittance, if we would like to represent the admittance of this network, which is composed of a large number of resistors and capacitors, this is basically how to present this admittance of this type of network, which is known in circuit theory. We already know that this type of admittance or infinite admittance is equivalent to what we call a fractional order capacitor. So in order to continue with our modeling of this device, which is very important in order to calculate its power and energy, we have to get some information or background about fractional order mathematics. What is the meaning of fractional calculus and how is it different from normal integer order calculus? So when we look at a fractional order capacitor, basically the main difference between this capacitor and the normal capacitor we know of is in the dispersion coefficient, something that we call the dispersion coefficient alpha, which means that the phase angle between the voltage and the current in this type of capacitor is not 90 degrees. So as undergraduate students, we all learned in university that we have three basic circuit elements: the resistor, the capacitor, and the inductor. And the resistor basically has the current and voltage always in phase. The inductor has current and voltage 90 degrees positive phase angle between the voltage and the current, and the capacitor should have the current and voltage out of phase by minus 90 degrees. In the case of the fractional order capacitor, which is basically used to model the supercapacitors, in this case, the phase angle between the voltage and current is not minus 90 degrees. It is less than that by this factor, which we call the dispersion coefficient alpha. So the phase angle between voltage and current basically is minus alpha multiplied by pi over 2, which is less than minus 90 degrees. There is also another famous name, which is widely used by people working in electrochemistry for this fractional order capacitor. They also call it the constant phase element, CPE, which stands for a constant phase element, because you can see that the phase is always constant independent of the frequency. However, it is not minus 90 degrees. Also, there is another famous impedance that is widely used in many applications, which is known as the Warburg impedance. And this is again a special capacitor. As you can see from this equation, this capacitor has a phase angle of 45 degrees, and the impedance in this case is proportional to the square root of omega. So it is not proportional to 1 over omega as we are used to in normal capacitors. It is proportional to the square root of the frequency. That is why it is given a special name, the Warburg impedance, but it is a special case of the general class of so-called fractional order capacitors, which basically are different from the classical capacitors that we all have studied in undergraduate studies. To illustrate the difference between the normal capacitor and the fractional order one, in this graph, you can see the relationship between the real and the imaginary parts of the impedance or the admittance of any fractional capacitor device. If we have an ideal capacitor, as you all know, it is pure imaginary impedance, so we should not have any real part in this impedance. If we have a pure resistance, of course, we should have all real values and no imaginary values. When we have a fractional order capacitor, this basically means that we have a straight line that you can see here with an inclination angle, and this inclination angle is given by the value of the phase shift between the voltage and current. In this case, it is alpha pi over 2. So you can see that the fractional capacitors or supercapacitors are by nature dissipative elements. They have resistive and they also have imaginary parts of their impedance values. This, of course, leads to something quite difficult in terms of mathematics. This leads to what we call fractional order differential equations. It is not the time in this presentation to go into details about fractional order differential equations. However, I just have to mention it because it is very important in the modeling of supercapacitors and in calculating their energy and their power capabilities, as you will see in the next slides. So these are two general definitions of what we call fractional order differential equations. This means we talk here about differential equations that have an order less than 1. So we can talk about half an order differential equation, or differential equation of order 2/3, or differential equation of order square root of 7, whatever the value. We are not restricted in this type of calculus to first order differential equation, second order differential equation, third order differential equation. We are not restricted to this type of mathematics when we look at fractional order systems. To understand also more, when we look, for example, at a simple function like the cosine function, cosine x, if we want to differentiate this function first order derivative or second order derivative, this means basically that we will see that the phase shift is always given by the order of the derivative n multiplied by the phase angle pi over 2. So you can shift the cosine function by an angle which is proportional to the derivative order n times pi over 2. When you perform fractional order differentiation, this means you can shift the cosine angle by a phase. This phase angle is not necessarily an integer value, so we can shift our cosine function, for example, by a phase angle alpha pi over 2. This means the phase shift here is not an integer multiple of pi over 2. This is basically to illustrate the difference between normal integer order derivatives or differential equations and fractional order differential equations. Now, one of the most important functions in mathematics, as we all know, is the exponential function. So the function f of t equals e to the power t is a classical exponential function. This function, when we look at fractional order derivatives or fractional order differential equations, it has an equivalent, which is known as the Maytag-Leffler function. It is, in other words, the generalized exponential function. And this generalized exponential function will appear whenever we try to model supercapacitors, whenever we try to find the step response, voltage step response, current step response. As we'll see in the next few slides, we will always be able to do that by using this general exponential function, which is called the Maytag-Leffler function. So you can basically look at this function as the general case of the exponential function. And again, I mean, there is, of course, no time in this presentation to go through the meaning or the from where we got this Maytag-Leffler function. But if you are interested, I can communicate with you after the presentation with more literature on fractional order systems. So just again to look at the basic concepts of fractional order trigonometry. This is the well-known Euler identity. This is the definition of the cosine and the sine functions. And these functions are not similar to the functions that we already know, except in the steady state. So for example, when we say that sine squared plus cosine squared should always equal 1, this case is not true. When we look at fractional order systems, this is true only in the steady state. As you can see in this numerical simulation, I am simulating here the value of cosine square t plus sine square t. And you can see that the sine square plus cosine square doesn't equal 1 except at the steady state value. That means when the time increases very much. In the transient phase, this well-known trigonometric identity is not true when we deal with fractional order capacitors or supercapacitors or any dispersive material that basically does not follow classical integer order differential equations, does not follow the classical differential equations that we all are aware of. It follows fractional order differential equations. In this case, we have to use different set of trigonometric identities, which are summarized here in this slide. So any questions until now, I can continue, or otherwise, if someone has a question, I can stop and answer the question.
Please, Professor, continue. Question will be at the end of the session.
Okay. Some of you may also wish to see how to transform fractional order differential equations from the time domain to the frequency domain. This is easily done by using Laplace transform, just like we do with differential equations of first order, second order, or any integer order. We can do the same for fractional order differential equations, and we can transform them into the frequency domain by using the Laplace transform. However, in this case, we need to pay attention to the stability, because the stability here is not similar to the case that we are used to dealing with right half plane and left half plane poles. Here we have to define what we call the S cone, the cone of stability with a phase angle given by the value alpha pi over 2. Whenever your poles are inside this cone, the system is unstable. Outside the cone, the system is stable. On the surface of the cone, the system becomes critically stable. So this is basically generalization of the right half plane, left half plane concepts in systems and stability. Finally, I can skip this slide. It talks about the impulse response of fractional order systems, which is also possible to do very easily by replacing the exponential function with the Maytag-Leffler function. So what our knowledge basically in integer order systems can be generalized easily to this type of fractional order system. So this is the mathematical part that we had to go through. I know it might not be an easy part, but it is important if we want to work in the modeling of supercapacitors and finding their response. So I'll go back again to the main topic or the main theme of my presentation, which is basically supercapacitors. We already introduced motivated the use of these devices, their internal structure, which is composed of carbon materials and electrolytes, and also the equivalence to an infinite RC3. Now we look at what is available in the market. So nowadays, you can easily get in the market capacitors up to 3,000 farad from different companies. We have NEC, Maxwell, Panasonic, and all of these companies produce a wide range of supercapacitors, 3,000, 2,000 farad. Even 1 farad is very small, and you can easily put it on a breadboard and start connecting components around this capacitor. So they are small, they have very large capacitance values. These things used to be impossible 10 years ago. Finding such a value of capacitance was nearly impossible. Today, they are available in the market. However, there is something that we have to realize about these commercial devices. All of them are low voltage devices. They cannot exceed 5 volts at most. Most of them are either 2.7 volts, as you can see here in this slide, the Maxwell 3000 farad, 2.7 volt DC is written on the device. So the voltages of these supercapacitors are very low, 2.7 or 5.5. This is the maximum available until today, and this is still a challenge to fabricate devices with higher voltage ratings. Also, these devices are unipolar. This means they cannot handle negative voltages, or they cannot handle opposite polarity. Only one polarity is allowed. They are very low frequency devices, as we will see in the next slide. So commercial supercapacitors are also compared to the capacitors that we know of. If we want to compare them with
Dr. Ahmed, yes? Please, you have 2 minutes, so to allow some time for the questions.
Okay, I'll try to speed up as much as possible, but okay. I'll do my best. Okay, so as you can see in this slide, the supercapacitors basically have very large values beyond the 1 farad when we compare them to normal capacitors. However, these supercapacitors have different behaviors, particularly when it comes to low frequency. So from this measurement that you can see, the real versus the imaginary, or basically the impedance of these devices, you can see that they cannot operate below 20 millihertz or 50 millihertz in some examples, in some devices. Otherwise, they become similar to what we mentioned at the beginning, the Warburg impedance with phase angle 45 degrees. So they basically have a transition from ideal capacitive behavior into more dispersive behavior at very low frequencies, such as 20 millihertz, 50 millihertz. This is not even reaching 1 hertz. And this means that when we want to measure these devices in the lab, we need really specific impedance analyzers, such as the 2 examples you can see here. One of them, I have actually both of them in my lab here. They can go down to 1 microhertz of frequency, and this is the only way to characterize these difficult energy storage devices below the 1 hertz level, sub-hertz basically level. Now there is an international standard to characterize these devices. As you can see here, the IEC 62391. This is an internationally accepted standard for how to characterize a supercapacitor. The problem with this standard is that it is very time consuming. It takes about 30 minutes in order to find the proper capacitance of any supercapacitor that you are dealing with. And that was a motivation for many of the research topics that we have been working on to reduce the time required in order to characterize and calculate the capacitance of these devices. I'll skip this. I'll skip also these 2 slides. I just want to show here that how to overcome the problem of the low voltage. So commercially available trams like this one, they are using what we call supercapacitor arrays. So because the individual capacitor has a rated voltage not exceeding 5 volts, in this case, for example, you can see 2.7 volts only. So the only way to have a large or a high voltage is to use an array of supercapacitors. In this example, we have 192 by 3 array, which delivers a total capacitance of a total voltage of 518 volts, total power of 1.5, energy 1.5 kilowatt hour. This is the total energy. And in the case of this tram, which is actually working in Austria. It can be recharged in 30 seconds, only in 30 seconds. Do I still have time, Dr. Mohammed?
Maybe 1 minute.
Okay, it's a long, I will do my best anyhow. So back to the fractional order model. So basically these are the models that you can see here are the most accepted ones in order to model the existing commercial supercapacitors. And the reason why we revised the fractional calculus at the beginning is that because the model here, as you can see, is composed of a resistor and a fractional order capacitor, which is basically a fractional order differential equation. Without these mathematical models, we are not able to calculate the power or energy. I will skip also these slides and just directly show you how to calculate the effective capacitance of a device. So these two equations are very important. You can see at the bottom that the capacitance of these devices is actually frequency dependent. So it is not a constant capacitor as we are used to. I cannot buy this capacitor, for example, which has the rating of 1 farad and use it at any frequency. It is usable, or this rating of 1 farad is correct once you start going down to the very low frequencies. As you can see here, for example, 1 millihertz, I am getting 0.8 farad, which is correct or very close to the manufacturer rating of 1 farad. If you try to increase the frequency, for example, to 50 millihertz, you will significantly lose the capacitance and it will start to drop very, very fast. So the effective capacitance of these devices basically depends on the operating frequency. Also, when you add them in parallel, they don't add as we expect from other normal capacitors. You have to pay attention when you add them in parallel. We also have to pay attention when we buy supercapacitors from different manufacturers, for example, NEC, Panasonic. If you connect them in parallel, they are different. They have different behaviors, even if they have the same manufacturer rating. So all of these are issues that we are dealing with when we purchase commercial supercapacitors devices. Now, I think I will finish this slide and stop for questions. So in this slide, I show you the step response of a typical supercapacitor based on the model and compared to the experimental measurements. So we have here examined two commercial supercapacitors. One of them is 1,500 farad and the other one is 3,000 farad. And the experimental data is clearly marked in dots. And the line or the fitted line comes from the equation that you can see here at the bottom of the slide. You can see clearly in this equation that the modeling of these devices is very difficult mathematically because we have to use functions like the Mittag-Leffler function that you can see here, which is a generalization of the exponential function. So this is the step response of this device, which accurately measures the experimental data. But as I said, to arrive to this response, we need a lot of mathematical background in order to be able to model these devices. I stop here, and I had some more slides, but the time is limited. So I think the previous slides are enough to get an idea or a background about this topic. And anyone who is interested, I will be very happy to share with you the presentation and any other material if you are interested to learn or work in this topic. Thank you very much for listening, and any questions are welcome.
Thank you very much, Dr. Ahmed. And now we have the floor open for question. I have question from, I guess, Dr. Mohammed Abbas. Maybe if you would like to ask your question by yourself.
Assalamu alaikum, Dr. Ahmed. Do you hear me? This is Dr. Mohammed Abbas from King Saud University. First of all, thank you so much for the very interesting presentation. In fact, I have two questions. The first one is related to the material that can be used as an insulator to increase the capacitance. Is there any direction to use what we call the high K material, like the hafnium oxide or something like that?
Doctor, thank you very much for the question. Actually, I am not on the material level of working in supercapacitors, so I will not be able to answer this question related to materials that much. I am more on the circuit and modeling side and also the application side of the supercapacitors. But there are a lot of publications on the fabrication of or creation of these supercapacitors. Different types of materials are being experimented, graphene and other types of materials, and different types of electrodes. So there is a lot of work in the electrochemistry society regarding the synthesis of these materials. It's not yet in the steady state, I believe, but honestly, I'm not an expert in this direction.
Okay, my second question is related to the capacitor performance itself. As you know that we need a fixed level of voltage during the operation of electronic circuit, which we can obtain from the battery, but I'm wondering whether we can have a supercapacitor with kind of fixed level of voltage during the discharging process. Is my question clear?
Yeah, I think so. It is clear. Well, actually, the okay, to answer actually this question, I think I can show you fast a short video that we had here, if there is time. So, can you see the slide here on the screen?
Yes.
So at the bottom here, this is an experiment in my lab. We just built a normal power supply running from 120 volts, and you have a bridge rectifier, and the capacitor in this bridge rectifier, which is typically an electrolytic capacitor, has been replaced with a 3 farad supercapacitor. So this is a normal power supply. However, instead of using a normal capacitor, it has been replaced with a 3 farad supercapacitor, and the circuit is driving a motor and some LEDs. So what you will see here is what happens when we switch off the power supply. Why are we using the supercapacitor in this case? I will just start the video. You will see in this video that you can see the voltage here on the screen of the oscilloscope. This is the regulated voltage. I think this answers your question. The voltage is regulated with the supercapacitor, and there is no problem at all. Once you switch
Dr.
off,
Ahmed, we don't see the video. I think you need to share the video. Share the maybe stop sharing the PowerPoint and share a screen with the video. Or the video is running on the PowerPoint?
Yeah, the video is running on the PowerPoint. So it is not clear?
I can see the video, but it's just the quarter of the slide.
Okay, I can increase the size of the video.
Yeah.
I think, I hope this is clear. Is this okay?
Yeah, that's very fine, yes.
Okay, and maybe delete this and delete this. So so what this video shows you is that here the voltage is being regulated to a constant level by using a supercapacitor, and there is no problem in the voltage level. Once we switch off the power supply, so there is no power here anymore, you can still see that the motor is running and the LEDs are running, and they are running from the power that has been stored in the supercapacitor only. So on the oscilloscope now, you will start seeing that the voltage level is declining, but of course it will decline very slowly because the supercapacitor already has enough charge to keep it running. So to answer your question, the first part of the oscilloscope trace here, which showed the voltage regulated output of the power supply, the supercapacitors perform excellent, just like normal capacitors. This is my understanding of your question.
Yeah, but just after you disconnect the power supply, the voltage start declining because the discharging of the capacitor.
Yes, the capacitor is now is the source of energy now in the circuit. There is no more power supply here, so the motor is running only on the supercapacitor voltage.
So still even the supercapacitor still cannot be used as a battery, right? This is the conclusion of the question.
Oh, yes, they cannot. They are not batteries, but they have an advantage when you compare them to batteries, is that they can deliver higher power. They can be recharged very fast. So basically, if you need the amount of power, for example, in this video that you are seeing, if this time that I'm running the motor for is enough, then I don't need a battery. I can run it from the supercapacitor, and later on, I can recharge the supercapacitor from the power supply.
Yeah, okay. Thank you so much, Dr. Ahmed, for the clear answer. Thank you.
You're welcome.
Shukran, Dr. Muhammad.
Okay, shukran, Dr. Muhammad. Okay, so do we have other questions? Now we have a question from Dr. Fathi. Dr. Fathi, please go ahead.
Okay, thank you, Abdullah, about your presentations. But I would like to ask you what's the ability of recharge the supercapacitor through wireless, the ability of this process.
Yes. Well, really, this is a very, very good question. And also, I was planning to show some of this in my presentation when I wanted to talk about the applications of supercapacitors. There are now a new class of supercapacitors which are basically dedicated for IoT sensors, wireless nodes, biomedical devices, and so on. So these new types of devices are being charged through wireless manners. But however, the amount of power that is stored in these supercapacitors is also much smaller than the large devices that we talked about during the presentation. So there is a lot of research going on now to fabricate what is called micro supercapacitors. And
yes.
On the screen here, I think the screen is clear, correct?
Yes, yes.
Yes,
Clear.
there are three. This is an example of three different articles, all of them talking about supercapacitors, particularly for biomedical devices and
Yes,
IoT.
it is my question. Yes, about biomedical applications.
Yes, yes, they are being used. As I said, this is like a new area. It's still not 100% mature, but there are a lot of publications on trying to use micro supercapacitors for implantable devices, biomedical devices, IoT sensors. They can be very easily charged, for example, from a solar power, and then they will operate the sensors or the biomedical devices for a sufficiently long time until they are recharged again.
But there is some papers, some research work really done in this area.
Yes, there is a lot already. Research work has been done. Yes.
Okay, I would like to thank you very much. Your presentation is nice, and we have to contact you. I think, Dr. Ahmed.
Inshallah, welcome. Inshallah. You're welcome.
Thank you very much, Dr. Fathi and Dr. Ahmed. I'm very sorry. I think we are running out of time, so I think I would like to conclude this session with thanking Dr. Ahmed Al-Wakil again for this interesting and very valuable information. And I hope we can see you again, but hopefully physically here in Egypt soon. So thank you, Dr. Ahmed, and thank you everyone.
Much, Dr. Muhammad, for the invitation, and I thank all the audience for their attention. And please feel free to share my contacts with anyone who's interested.
Yes, sure. Thank you, Dr. Ahmed.
Thank you very much. Assalamu alaikum.
Alaikum assalam wa barakatuh.
Okay.
Okay, I would like to thank the session chairs again and the speaker. We are going to move to the last talk in our workshop today. The talk will be presented by Professor Muhammad Abu Zahad. The session chair will be Professor Mona Shukir from Munufia University, Professor Osama Omar from Aswan University, and Professor Sabah Muhammad Ahmed from EJUST. I think Professor Mona is here. Professor Osama Omar, I can't find him in the list. If he is here, just raise your hand, please, so I can just change the rule. The talk will be given by Professor Muhammad Abu Zahad. So I give the floor to Professor Mona Shukir to introduce the talk. Okay, Professor Mona, you can start the microphone. Switch on the microphone, please. Professor Mona Shukair, can you hear us? Please turn on your microphone to hear us.
Dr. Ahmed, can you hear me?
Yes, Professor. You can hear you clearly, and the presentation is already on that screen. We can see it. I'm just waiting the session chairs to take the lead for this session.
Professor Mona is here?
She is here, but she cannot hear, I think, us.
She is now a panelist, or maybe...
She's a panelist, yes, she's a panelist, but... her mic is muted. Yes, her mic is muted. I'm trying to ask her to unmute her mic, but it seems there is something not clear. ما اعرفش تروس واحدة ما عملتش شيء.
Dr. Saraf can chair the session if he is here.
Okay, I think Professor Muhammad Sharaf is here. I think he can present our speaker, then we will see.
Okay, thank you very much. This is Muhammad Sharaf from EJUST. It's my pleasure to introduce our last but not least speaker in our conference, Professor Muhammad Abu Zahad, to talk about the next generation wireless communication for smart cities. Professor Muhammad received his bachelor and master degree in electrical engineering from Asyut University. And he got his PhD from the University of Kent at Canterbury, UK. And he is currently a professor at Egypt Japan University of Science and Technology and the Dean of Faculty of the School of Electronics and Communication and Computer Engineering. Professor Muhammad is very active in several research projects and several conference committees. Professor Muhammad interest mainly in biomedical and bioinformatics and of course communication, optical digital filter, switched capacitor, data compression, wavelet transformation, and he's well known in the field of digital signal processing. So Professor Muhammad, you have the floor. You can start.
Okay, thank you, Professor Muhammad Sharaf. It's my pleasure to introduce our lab, the Wireless Communication Lab for Smart Cities, in this presentation. In fact, we have to first define what does the smart city mean. There is no single acceptable definition of smart city, but most rely on the use of technology and evidence to improve cities and services. In fact, the smart city means digital client, digital community, digital citizen, inclusive digital city, visitor to digital city servant and representative, technological and organizational preconditions, digital city economy, innovative and experimenting, sustainability. There are three main dimensions of smart cities and sustainable cities. The first dimension is the sustainability, the second is the smartness, and the third is the quality of life. And there are a lot of challenges for smart cities. The first is the traffic will continue to increase about 1,000 times by 2020, and the number of connected devices will increase about 10 to 100 times by 2020. International definition of smart cities. A smart city, a smart sustainable city is an innovative city that uses information and communication technologies, ICTs, and other means to improve quality of life efficiently in operation, services, and competitiveness, while ensuring that it meets the needs of present and future generations with respect to economic, social, environment, as well as cultural aspects. In fact, smart cities use 5G technology, and 5G technology is expected to support the transition to smart homes and buildings, smart cities, telemedicine, 3D videos, cloud computing, virtual reality, and more. The most important thing that is related to smart cities, in fact, is the Internet of Things. There are two categories of Internet of Things currently used. The first is people connecting to things, and the other is things connected to things. For example, for vehicle communication, we can see a lot of cars connected to each other, connected to the police car. All over the world, I think we have about 100 smart cities, but the top 25 smart cities in the world are located as in the map. For example, there is a smart city in United Kingdom. It is in London. Also, there is another one in Paris, Stockholm, Sweden, Tokyo, Japan, Amsterdam, Netherlands, New York, United States, Vienna, Austria, Seoul, South Korea, and Singapore. In the Arab area or Middle East area, there is a smart city in Dubai. For the second year in a row, New York has been declared the smartest city in the world. A lot of components exist in smart cities. For example, as I mentioned before, smart governance and smart education, smart healthcare, smart buildings, smart mobility, smart infrastructure, smart technology, smart energy, and finally, smart citizen. For example, for infrastructure and transportation of the future in smart cities, we can see the video, it's a short video. Is it clear?
The world is changing fast. Cities are growing and urban population is rising.
Yes,
the
Dr.
need for transport of people and goods are increasing, but so is congestion, air pollution, road accidents, and climate change. We need more mobility, but we have to do it in a smarter way. This is our scenario for the future. Outside the city, vehicles and autonomous trailers are operating within safe and confined areas. Electric vehicles are charged while goods are loaded. A driver enters to lead the connected convoy onto the public roads, where dedicated bus lanes should be used if possible. Autonomous connected trailers create safe, modular, and flexible vehicle convoys, adapting to transportation needs. Adjusting to schedule updates, the flexible convoy, switching goods along the way, a mobile consolidation center. The transport system is enabled through an integrated cloud platform, connecting vehicles, people, infrastructure, and logistic partners. In the city, the sensors of the autonomous refuse truck detect all movements in the vicinity of the environment and reacts automatically to any potential incidents, making sure citizens are safe and preventing accidents before they happen. Bus platooning will improve efficiency and capacity in city public transportation. With silent emission-free buses, we can bring public transport closer to people and even drive inside of buildings. This opens up completely new opportunities for city planning. Fast and efficient way of charging from the electric grid at the end terminal in just a few minutes. How do we build the cities and the infrastructure of tomorrow in a more sustainable way? The future is electric. Zero emission and low noise gives the electric compact excavator access to environmental zones in the city. Imagine a silent and emission-free city. Imagine a cleaner, safer, and more resource-efficient world without compromising our everyday life and health.
Is it clear? The voice is clear?
Yes, doctor, it was clear.
Okay. In fact, IoT is an emerging technologies that have grown services and applications in various areas, including smart cities, healthcare, transportation, logistics, retail, safety, and security. During 2008, the number of things connected to the internet exceeded the number of people on the earth. But today, by 2020, there will be about 50 billion things connected to each other. For example, vehicles, pets, assets, persons can be monitored or controlled. Agriculture automation, as Dr. Ahmed Khattab mentioned in his interesting presentation, agriculture now can be automated through Internet of Things, energy consumption, security, building management, embedded mobile, a lot of applications everywhere, every time, every day, a lot of applications for Internet of Things. In fact, nowadays, two terms are too common, but the most common term is IoT, which is an Internet of Things. Internet of Things mainly includes devices and how they connect to each other or to people. But there is another term which we call the Internet of Everything, IoE. In fact, Internet of Everything has a broader scope and impacts many essential components of everyday life. As we currently know, people can be connected through things, data can be manipulated between things and people. In network domain, network of physical devices and items embedded with electronics to enable connectivity and to exchange data is a feature of Internet of Things. However, broader concept than Internet of Things, which defined as the intelligent connection of people, processes, data, and things, is called Internet of Everything. For Internet of Things, communication occurs between machine to machine. However, in Internet of Everything, communication occurs between machine to machine, machine to people, and technology-assisted people, are what we call P2P. So IoT is less expensive than IoE. However, IoE is advanced more than IoT. What are the main opportunities of IoT? In fact, in the communication domain, in near future, or I mean by the end of this year, about 7 connected devices per person will be the common. For shoppers, about 71% from the shoppers will do their business through Internet of Everything. And also, even in industry and medical domain, a lot of application is growing, and this is an opportunity of the popularity of IoT. As I mentioned, in 2015, the number of people in the world was 7.2 billion, and the number of Internet of Things about 25 billion. But after 2 years, I mean in 2020, the increase in the population is not too much. It increases from 7.2 up to 7.6 billion. However, the number of connected things increased from 25 up to 50. I mean, increased the double. The main question which we can ask is, can smart cities exist in Egypt? With Cairo, the second most densely populated city in the world, according to 2020 World Population Review, the government has been working on relocating capitals of 20 million plus residents and expected to double this number in the next few decades. It plans to build 26 new cities according to the new Urban Community Authority, including a new administrative capital, a new Al-Amin city, and a new Luxor. The new administrative capital is a mega project in Egypt that has been under construction since 2015 on about 700 square kilometers total area. Although its name is still unknown, the authorities say it will be a smart city capable of housing 6.5 million people. The city will be equipped, the city means the new administrative capital city will be equipped with several sensors, intelligent traffic, and smart energy system. It will have a huge green area, mega shopping center, residential areas, and science and technology campuses, and culture complex, including opera house, theaters, and cinema. The answer of this question, can smart cities exist in Egypt, is the answer is not yet, but it is in process. We can watch another video for we can watch another, sorry, where is the video is not running.
The world is using technology more creatively than ever, and as it does, tech is being integrated into every facet of our daily lives. The digitization of government and community services is now widespread. For example, smart cities that use technology to foster a better relationship between government and citizens has truly arrived. By utilizing data, cloud computing, and artificial intelligence, big cities are transformed into smart cities around the globe. When we're connected with the internet, smartphones, urban managers can more easily decipher our needs, better allocate public resources, and make decisions that improve quality of life. Hangzhou, a megacity in China's Zhejiang province, has had a digitized city management system for 5 years. When it was first implemented, it focused on dealing with traffic jams. Now the digitized system is integrated across the board. The online program is expanded to include police, transport, tourism, health, and other major operations. Traffic congestion is one of the biggest headaches of modern urban life, and Hangzhou is no stranger to this. In 2013, it ranked 3rd in China's traffic congestion index, but has since dropped to 35th place. So how did one city improve 32 places? Well, Hangzhou is handling traffic and parking as a joint problem. Its City Brain project, run through the Alibaba cloud, manages real-time traffic for 1,300 traffic lights. It increased traffic flow by 15% in its first year and increased ambulance arrival speeds by nearly 50%, indicating clearer roads and less congestion. With the COVID-19 outbreak, smart city tech is also giving new hope and new ideas for how cities can run efficiently and safely. Hangzhou's capacity to use tech to prepare for an outbreak and track the speed of disease is invaluable. Since COVID-19, Hangzhou has used health ID barcodes and cloud services to track, control, and prevent the spread of viruses. These barcodes, launched in mid-February, are scanned as users move around the city and categorize them into green, yellow, and red. A green barcode indicates its holder is healthy, while those with red and yellow need to be isolated. They can only travel or return to work when their barcode is As the world moves to increased digital integration, undoubtedly there are complex questions about privacy and security that go hand in hand with the services that will alleviate major issues and improve lives. These are tough questions that cities and countries around the world will have to tackle to find their own preferred balance. But tech-powered governance as carried out through innovative management technologies like in Hangzhou can be a major enhancement of governance itself by personalizing city management and allowing it to cater directly to the people. Greater synergy between a city's residents and its government can be found, and it can benefit people and societies everywhere.
Okay, some basic requirements for smart cities, supporting perception of infinite capacity, tactile internet, the internet interacts with the world. Augmented reality means enhancing what you see. For 5G network will need to be more available, more dependable, more reliable, and offer increased speed, increased throughput, decreased latency, improved device autonomy. We hope, of course, that all of these basic requirements can be offered at a low cost. In fact, we will deal with two frequency bands. The first frequency band is the sub-6 gigahertz band, and the other is the 5G millimeter wave, which extends from 24 gigahertz up to 300 gigahertz band. As everyone knows, the story started by first G or 1G. In that case, the communication was through voice, and in 2G, the communication is a digital voice plus simple data plus SMS. In 3G and 4G, mobile broadband exists. But the big change was on 5G because the number of things increased to about 500 billion things. For 5G growth opportunity for smart cities, in fact, 5G provides promising faster data speeds and lower latency to consumers. Also, it opens up avenues to new industrial application and is a critical element to build widely connected devices to improve operations. Massive MIMO from 64 up 256 antennas offers performance up to 10 times current 4G network. The 5G frequency bands include millimeter wave band, sub-gigahertz band, low band up to 5 gig, and low band 5G and mid band 5G. This is a third video, it's a very short video, but focuses on the application of 5G in smart cities.
Look at the goal of smart city and healthcare. How can we have a connected ambulance that's getting that instant information to and from the ambulance? Not only so the information is available within the ambulance patient, but also so the patient's information is available at the hospital for when you pull up to them. If we then think about the ultra reliability and the low latency communication, they come particularly handy with any use case where you have something either dangerous or expensive moving, and where we need to have a very reliable connection to that object. So we're very optimistic that not only will cities and companies work together to enable smarter connected cities, this will also result in meaningful improvements in terms of the safety of operation of the city.
There's just a ton of different use cases that can make
5G will better enable autonomous busing, public transit, adding the more efficient elements to that.
So it's important that we create this type of platform where different types of software companies, different types of business models can flourish.
Everything from things like video surveillance, controlling machines and vehicles, and IoT as well, so massive machine type communication, which being able to improve the quality of life for everybody inside.
5G challenges in smart cities, the key parameters for operation of smart city applications are the coverage, the data rates, and the possible number of connected devices. For 5G, 5G is intended to operate in the sub-6 GHz band and in the millimeter wave band, building a configurable MIMO test bed in the sub-6 GHz band, which can be gathered to be the centralized massive MIMO or several IoT nodes in the smart cities is going to provide a unique opportunity to researchers and industry to test several setups in real implementation systems. As one prominent test case for the millimeter wave in smart cities application is the vehicle-to-vehicle communication, V2V communication. Our lab is financially supported by STDF. The budget is about 10 million Egyptian pound, and the duration of the project is 24 months. The lab teams, I am the PI of the lab. My specialty is wireless sensor networks, massive MIMO, and multimedia processing. The co-PI is Professor Mahas Saproti. Professor Mahas' specialization is in wireless communication, massive MIMO, cognitive radio, and IoT. Professor Sabah Ahmed, wireless communication, biomedical signal processing. Professor Adil Abdulrahman, his specialization is in antenna design and millimeter wave antennas. Dr. Ahmed Abdel Malik, cognitive radio, physical layer security, mixed RF FSO, and engineer Ramil Amrawi, telecom and network engineer in Huawei and in Huawei and Vodafone. Our collaboration partners nationally, joint research collaboration with AUC in the area of application in smart cities, with the research talent in Egypt, AUC valuable research in 5G area is expected to place Egypt as a leading country in 5G validated research in the region. Internationally, Egypt's next generation wireless communication lab for smart cities has a strong support from the following research labs: wireless communication lab at Hijau Faculty of Engineering Technology at Yarmouk University, Jordan, for implementing the potential research work for wireless communication technologies in smart cities. Professor Ahmed Lailuni is the contact person with the Yarmouk University. Wireless communication lab at Kyushu University, Japan, has a long history with us in collaboration with eJust Lab and the supervision of students. Also, Professor Osama Mota is the contact person with Kyushu University. Wireless communication lab at KFU PM, Saudi Arabia, will collaborate with eJust Lab. Professor Salama Zumo is the contact person through Dr. Ahmed Abdel Malik, eJust. These are the letters of cooperation between eJust and the other national and international partners. eJust is a member in the innovative cluster of IoT and smart cities in Burj Al Arab. The cluster involves key players in IoT and smart cities who will be highly interested in test beds for testing their developed algorithms by building the first sub-6 GHz and the millimeter wave band test beds. We directly enable researchers in Egypt, Japan, Jordan, Saudi Arabia, and the region, both in academia and industry, to conduct realistic experiments, channel modeling, and test cases for important smart cities applications. In fact, all Egyptian universities and higher institutes are invited to collaborate with us as a partner. This is a sample of recent publications of the lab team, most of them in IEEE Access and IEEE Internet of Things, and in highly ranked journals. The research areas of the wireless communication lab are the 5G wireless technology, cognitive radio networks, NOMA, cooperative communications, network classification, massive MIMO, interference management techniques, game theory application, wireless communication, energy harvesting and green communication, physical layer security, and IoT. These are the main research areas of the lab. Current status of the millimeter wave and massive MIMO test beds in Egypt. Unfortunately, currently massive MIMO and millimeter wave test beds for the two dedicated bands are lacking in Egypt. On the millimeter wave front, there is no lab in the region that has yet developed a test bed to serve experiments in this important spectrum portion. Regarding the sub-gigahertz band, the Wireless Research Lab in Egypt has started pioneering effort to develop test beds for higher order MIMO in collaboration with the National Telecommunication Authority, Regulation Authority, NTRA. However, reaching truly massive MIMO requires a dedicated project budget. Currently in Egypt, we built on the already existing advanced wireless equipment for national research community and completing the test bed in 5G by introducing a configurable massive MIMO multi-node test beds in the sub-6 GHz band and the first MIMO millimeter test bed to cover the real 5G operation and different smart cities test cases. The services offered by our lab. The lab is a hub for 5G wireless communication research in Egypt and the region. The lab will offer test beds and identify national challenges that can be tested to accelerate the research and development of smart cities IoT applications. The lab has accessible websites to promote the collaboration with the ICT industry in relevant problems to establish a strong R&D sector in the wireless communication industry and academia. Organizing this workshop in the scope of next generation wireless communication for smart cities every year to discuss the applications and study cases of smart cities according to the national challenges. The goals of the lab is to study, investigate, and provide solutions for the key challenges that will face the deployment of configurable 5G massive MIMO and millimeter wave cellular networks in the area of IoT applications for smart cities, to develop the first integrated test bed in millimeter wave band as the first test bed of its kind in Egypt and the region, to complete the available sub-6 GHz massive MIMO test bed in Egypt, to enable integrated comprehensive testing and verification, to develop a taxonomy of applications to operate in the complete spectrum in the scope of IoT and smart cities to help developing national competency and starting serious R&D in Egyptian ICT-related industries. The results of such cooperation with industry would support dedicated research towards the next generation mobile communication systems. This early access to the problems and challenges will give Egypt the chance to contribute actively in the communication scheme. Organizing open lab events for academia and industry for further cooperation. Also, all the lab activities will be posted in a website associated with the host institution website. The outcomes of the project: a complete massive MIMO base station reference design and to act as a meeting point among engineers in the field, supporting the teaching and the research of the new postgrad degrees in advanced wireless communications, millimeter wave, and IoT. 2 master degree students and 1 postdoctoral research in 5G communication systems and beyond, and conduct experimental research with industrial value, strengthening the national international cooperation. Currently, the wireless research lab in Egypt has turned focused on applied research through collaboration with other labs on developing a test bed for higher order MIMO through a research project. This enables the researcher to test their developed 5G-oriented communication algorithms to validate their performance rather than relying on simulation. One of the aims is to promote the young researchers. The School of Electronics, Communication, and Computer Engineering at EJUST has more than 60 graduate postgrad students, and most of them are beneficial of this lab. Currently, ECC has more than 50 national and international registered students. The expected young researchers to be added include 2 master students, 1 doctoral student, and 1 postdoctoral colleague. All will participate in developing new technologies in the area of the proposed lab activities. It is expected that the research in this area will result in several publications in impacted journals and 1 patent. The test bed enables the researcher to test their developed 5G-oriented communication algorithms to validate their performance rather than relying on simulation. Moreover, one of our team, Dr. Ahmed Abdel Malik, is a young researcher who can get benefit from the lab to conduct high-impact research in the area of wireless communication technologies for smart cities. A sample of our students, we have so far 3 international master students, and currently we have a lot of Egyptian national students. Engineer Minna and Engineer Basant are 2 examples of good students. And we have a lot of alumni who are now in their universities from different universities, University of Panham, Nufaya, Al-Azhar, Asyut, Suez Canal, Tanta, Ain Shams, and the Nuclear Research Center. We are organizing ECC school organized the JAC-ECC conference annually. This is the 8th run with collaboration with Kyushu University and STDF. The 5th 5G forum can be held jointly with JAC-ECC. This workshop is a window for cooperation between specialists in the field. These are the research areas of the team members I mentioned before, no need to repeat. All over the world, up to our knowledge, there are 4 centers that have test beds. These are the University of Texas. University of Texas has a millimeter wave and radar test bed. Bristol University has a massive MIMO test bed. Lund University has a massive MIMO test bed. Singapore has a 5G developed excellent of sensor, excellent center for 5G. The major equipments available in each JAC are a set of NIUSRBs from different families, real-time MIMO channel emulator, MATLAB and Simulink licensed software, advanced cloud system for big data analytics, and remote access to different equipments, IoT lab equipped with a variety of sensors. These are the current existing equipments in JAC. These are a set of new equipments that we will provide soon, and the cost of these instruments is about 10 million Egyptian pound. All of these instruments is available to all Egyptian students in all universities, even private and higher institutions. Concerning the long-term and short-term sustainability plan, we expect the lab and the test bed to be dedicated to research. We plan to develop several research and test cases for the smart cities as a future application. The yearly workshop will serve identify the national and forthcoming challenges in the smart cities that can be modeled and solved through the test beds. Application for research grants, both nationally and internationally, will be the main source for sustainability, in addition to providing technical courses on smart cities and the use cases of the test beds. It is also the intention of the research group to build up on the capacity building grant proposed to a large-scale center of excellence in smart cities that is planned to be consortium of research universities and institutions inserted in accelerating the application of the smart cities. These are a set of references from colleagues in the labs and colleagues in other universities related to our lab. Thank you very much. Any questions? Okay.
Thank you, Professor Mohammed. I will leave the floor to Professor Mona, the chair of the session.
Okay.
Please, Professor Mona, unmute the mic.
Can you listen me now?
Yes.
Yes, I wanted to ask Professor Mohammed how many antenna massive MIMO applied in EJAST now to reach to massive MIMO. How many antenna until now reached in your lab?
Currently, we have about 32 antennas, Professor.
How many?
We are upgrading the current up to 32. Currently, we have 16.
I don't know. And how about range of millimeter wave? how can change from microwave to millimeter wave actually in currently in your research? Range millimeter wave.
In fact, the current digital devices can support the millimeter wave. The lab, which is supported by STDF, will support the millimeter wave range up to 100 gigahertz.
100 gigahertz. How can EJAST support 5G in Egypt?
Sorry?
How can EJAST support applying 5G in Egypt?
Okay, we are constructing this lab, which includes two main test beds. The test bed is a massive MIMO test bed, and the other is a millimeter wave test bed. And any colleague from any university can visit us for a short or a long period of time to use these devices to test his applications.
From your opinion, in Egypt, how can reach to 5G technology in Egypt apply in all Egypt? From your opinion?
I think we still need about 2 years more.
2 years more and apply 5G technology?
Yes, in my opinion. Maybe we will start by the new capital city. Because,
thank you, Professor.
Not at all. Because you know that this needs a lot of money. And even in USA, not all places is covered by 5G.
Thank you, Professor Muhammad. Thank you. Thank you.
I think we have another question from Professor Fathi Farag.
Okay.
Yes. Yes, I can. Dr. Muhammad.
Yes, Professor Fathi.
Thanks a lot for your representation and your information about it mentioned in your representation. That now, as a researcher, what is required from us to, especially in the area of electronic circuit design, what you need from us to going to be in 5G?
In fact, our domain is completely different than your domain, Professor Fathi.
Yes.
Because you are an electronics design professor, but we are communication professors in 5G and beyond.
Yes.
We may find a common research point between our group and your group.
Okay, but I need to ask to specifications from up to what giga we need to work.
You know that I am a supervisor of one of your students in the university, and she is working in 5G. And I think we will start by her and Dr. Abdel Hamid to use our facilities to improve the research capabilities of your students.
Okay, we can discuss after with this team, inshallah. Thank you for your question, your answering. Yes.
Thank you.
Okay, thank you, Professor Fathi. Any more questions? I think Professor Muhammad Abbas Hando, so I have a question.
Assalamu alaikum, Muhammad.
Alaikum assalam.
Thanks so much for the very interesting presentation. My question, actually, it's a kind of comment. Do you think it's the time to upgrade the undergraduate courses to include the 5G technology? Because I think our bylaws, even in ASUT or any other university in Egypt, the 5G technology is not included yet. So do you think that this is one of the possible recommendation for the conference to upgrade the bylaws for the university to teaching the 5G technology?
I will speak about EJAST, then about ASUT, because ASUT is my university as well. In EJUST, we are teaching 5G in wireless communication courses. But in ASYOT, I am advising Dr. Omar and colleagues in ASYOT University to jump the 5G era to the 6G, because if they planning to include 5G now, and the bylaws will be checked and approved next year, after that, the 5G will be obsolete. So I am advising them to bridge the 4G and 5G to the 6G.
Even for the undergraduate?
Even in undergrad.
I see. Thanks so much, Professor.
Thank you, Professor Muhammad Abbas. We have another question from Dr. Ahmed Gadallah.
Yes.
Okay, you can.
Hello, Professor Abu Zahad. I am Ahmed Gadallah from IHP Germany, Innovation for High Performance Microelectronics. Actually, I am one of the master graduate students from EJUST, and now I am pursuing my PhD at Ulm University and IHP. Actually, here at IHP, we are working at this 5G research, but in circuits. So my question is, there is any intention in the future for EJUST to to go in this area of research, not regarding to only wireless communication, but also for the circuits, because actually I think in Egypt no one is doing this research now in circuits. I know that the facilities is not enough to do this research, but I think Kyushu University, they have this technology, they have the most technology. I think they can push this technology to work at these 5G frequencies.
Okay, thank you, Dr. Ahmed. I'm glad to hear you, because we are always in our presentation show others your picture and that you are one of our good students.
Thank you.
Okay. In fact, as a dean, I will push Dr. Alam, who is a specialist in the RF circuits, and Dr. Adel Abdulrahman to apply for a grant from STDF or NETRA or other supporting agents for such a lab. I mean RF circuits lab, for example, or not RF, but 5G circuits. Let us call it 5G circuits lab. I will push them to apply for such a lab, and I think STDF supports very well new technologies, because when we applied for this lab, it has been accepted from the first round. So STDF and NETRA and other supporting agents support the new technologies very well. And I have to thank all of them for their support to EJUST, especially, and to all Egyptian university researchers and professors. I promise you to work hard with Dr. Alam and Dr. Adil and Dr. Muhammad Sharaf to form such a lab.
Thank you, Professor. And from my side, I can help also any of students who would like to go deeply in this area of research. I can help them personally, actually. So it is very interesting now, especially like now people are actually going from millimeter wave to terahertz communication systems. So, and this is very, very open research area. And like there are many publications in very strong journals actually related to this research area. So also I can help personally anyone who would like to know more about millimeter wave circuit design and like new technologies, especially because actually we at IHP, we have like a very, very strong silicon germanium technology. So thank you, Professor, and I hope that you just go.
Ahmed, because Dr. Fathi Faraj from the Azir University just asking me about the collaboration in the circuit domain in this high frequency range. And this is a chance to have a collaboration with us and to the Gazig University and Professor Fathi especially.
Of course.
Okay, we will send your contacts to him.
Okay, no problem.
Your contacts with Professor Adil and Professor Alam. And
yes,
there will be a cooperation between us, you, and other Egyptian universities. And we are proud of you, Ahmed.
Thank you, Professor.
Okay.
This is my pleasure.
Thank you, Dr. Muhammad, for this link. I think I am looking forward for this link.
Okay,
from my side, Dr. Fathi Faraj.
Of course, Dr. Fathi, I can send you my contact directly, actually. So
okay, shukran, Dr. Ahmed.
Dr. Ahmed Jad, do you know Professor Asano from Japan?
No, actually, I just worked with Professor Ramesh Pokharel and Professor Jaya, but
Professor Asano is working on circuits in terahertz range.
But which university?
He is in Kyushu also. He is in Kyushu University, but he is always visiting us 3 times a year. And it's a chance to work, all of us. I mean, your university is just the Azir University and even Kyushu University through Professor Asano.
Of course.
Okay, thank you, Ahmed.
Thank you, Professor.
Please, Professor Abzahad, I want to mention something.
Yes, please.
Hello, I am Adil Abdurrahman, and me and Dr. Alam were the supervisor of Engineer Ahmed, and he was one of our best students in our RF and the microwave lab in Egypt. And we are proud that he is now working in the level of international and worldwide level. And my information about Ahmed that he is working now in Germany. Am I right, Ahmed?
Yes, Professor Adil, yes.
Yes, okay. And it is our pleasure that we can continue cooperation with you, of course, and we can continue in the millimeter wave range devices, active or passive devices. Of course, it is our pleasure that we can work in the international level also. Thank you.
Thank you, Dr. Adil. By the way, I am very happy today to be asked from Professor Muhammad Abbas and from Professor Fathi Faraj, because I was their supervisor in their masters. And now both of them is a very famous and excellent professor. Professor Muhammad Abbas is the first postgraduate student of mine. And I'm very happy to be asked from him and to be asked from Professor Fathi Faraj. Thank you.
Dr. Muhammad, it is our pleasure. It is our honor to be your supervisor of us.
Thank you, Professor.
Professor Mona Shukr, do you have any more questions?
Thank you so much. Thank you so much.
Okay, I think we reached the end of this session. I leave the floor to Professor Muhammad, the conference chair, to conclude and close up the conference.
Okay, thank you, Dr. Ahmed, for your efforts, for Dr. Alam, Dr. Sharaf, all colleagues in the school. I am very happy to work with you all. I have to thank all conference sessions chairs for their efforts. Also, I have to thank all reviewers, and I would like to thank our colleagues from Kyushu University, especially Professor Koji, Professor Asano, and Professor Usama Muta. Thank you all for your efforts to make this conference real, even in this very difficult time. Thank you all. We reached the end of the conference, and we will see all of you next year, inshallah. Okay, Ahmed.
Thank you, Professor Muhammad. At the end, I would like to thank all of the audience, our chair sessions, our authors, and our organizing committee and our Japanese partner for their continuous effort and collaboration to make this event happen. I wish you all have a good night and see you next year in JAC-ECC 2021. Assalamu alaikum.
Alaikum assalam.